What is crack liking, peoples? What is up? We are back with my journey to 100 videos every single day. Anyways, we have a new game, and this time we have a Unity game. It's a 2D shooter. It's a really cool game. I call it the Mad Doctor because, you know, I'm a mad developer. Let me just shut up. You don't want to hear these things, so let me just go and show you the game that we want to, or that we will create. So over here, as you can see, we have a really cool doctor, and these red points that you see are the spawning points where the enemies are going to spawn, and if I hit the play button, you are going to see now that, well, we hear the BG music, and now we're going to see the enemies being spawned over here, and all of that stuff. Let me just turn off the BG music, because why do we need the BG music? So I'm just going to turn it off. This is just here for showcase so that we can hear and see that we have BG music. And if I hit the play button, now we are going to see again, as I said, we have our health bar at the top left. We have the Mad Doctor who is moving. He can shoot. You can hear his shooting, and we will have enemies who are going to attack us. The enemies are going to have health bars, as you can see, and I can shoot the enemies. As you can see, 3 times if I shoot them, they are going to die and disappear from the game. And you can see here at the top left corner, I have the enemies killed counter, and of course the enemies can kill me as well. So let me just get close to the enemies. Here they are. So one, well, of course they don't deal that damage, you know, because I am a cheater by nature. I cheat in every game that I play, but let me just, you know, slowly walk you through and let me just go here and actually change the player health. So currently it's 25, 15, there you go. Now the player is going to die. Voila, the player has died, and now the game is going to restart. And that would be pretty much it. It's a really cool game where we are going to create a weapon, shoot with that weapon, create multiple enemies, actually only one enemy, but spawn them multiple times, and, you know, allow the enemy to attack us and all of that stuff. So we're going to learn a lot of cool things, especially enemy AI, especially with some simple logic, how we can create, you know, complex systems, as always what I do in my courses. Anyways, I don't think I have anything else clever to say except, you know, stay out of jail, I guess, because if you're in jail, you cannot follow this tutorial. And I will see you, well, in the next video. Take care. All right, my game dev gangster, let's do this. The first thing that I'm going to do, as always, is import the assets. And here they are, and you can download the assets. Link will be in the description down below. You can just click on that, and then you will, you know, download the assets. And basically what we need to do is simply select all of these and drag and drop them right here. And of course, wait a moment or two. I know this is not Unreal Engine, but, you know, sometimes it takes Unreal Engine time to load the assets. And by the way, it's raining outside, so I'm trying my best to bring you all of this content while I am also avoiding thunder. So yeah, it's raining, man. Just ignore what I said right now. So over here inside of the scenes, I'm also going to rename this one to gameplay. No need for this, but you know, I am weird. I do weird things. You watch weird people on YouTube, which is me. So the first thing that we are going to do is we are going to create our backgrounds, who are located over here in the sprites and then background. So here you have left, right, middle, up, down, you know, you get the point. So I am going to right click and create an empty game object over here. And this one is going to be our backgrounds, or basically the holder who's going to hold all of these backgrounds. I'm going to reset the position, so X, Y, and Z will be at 0, and we are going to start with the background middle. So I'm going to drag the background middle, and I'm going to position it, well, in the middle. I am going to resize the scale to 0.5 or 1.5, 1.5 on both axes, and this will practically be our background. Now, one thing that I'm going to do is I am going to create sorting layers. So over here, I'm going to click, and by the way, you saw where that is. So it's here in the sprite render, and over here, sorting layer, click on the add, or click here where it says default, and from here, add sorting layer. So we will need a sorting layer for the background. So this is going to be one sorting layer. Another is going to be for the bullet. So click on the plus over here. We're going to have bullet. We're also going to have one for the enemy. So enemy. We're also going to have one for the player. So click here and we're going to have one for the player. And last but not least, we are going to have one for the UI. I'm going to create, or I just created all of these right now so that I don't have to go back and forth. You know, for example, when I create the player, so I don't have to be, oh, no, let's create the player layer. No, I have all the layers, so background, bullet, enemy, and player. And by the way, you should know what these layers are. We covered this already. I covered that in numerous of videos of mine on YouTube, also in my Game Development Academy with my courses that you can get. Link will be down below, by the way. Now, as I said, so the sorting layers will determine the rendering order, which basically means if I take this right here, so annotate screen, that the background layer will be rendered, you know, last. And why is, I need to fix this. I don't know what I did with this, you know, so I will fix it for the next video. Anyways, the background layer will be rendered first, then the bullet, then the enemy, then the player, then the UI. Basically meaning, for example, in this right here, UI will be rendered on top of all of these other elements. Player will be rendered on top of the enemy, and so on and so forth. So for the background middle over here, sorting layer is going to be the background. I mean, which is, you know, what else did you expect? Next, we're going to take here the background left, and I'm going to simply drag it here into the background. So now, as you can see right away, if I click, this is, you see, this is background left. It's rendered behind the background middle because the background middle is on the background layer and the background left is on the default layer. So I'm going to change him back to the background layer. It's still not visible because, you know, both of these are on order in layer 0. So if I move this one on order in layer 1, there you go, he will be rendered on top. But I'm going to put him back to 0, and I'm going to position him to negative 48.68 and 0.7 on the y-axis, and this is where he is. And I'm also going to 1.5 his x and y scale. He should be down a little bit. Let me just select him. Okay. Weird. There you go. Let me just see here, backgrounds, this is on the one, this right here, background, and okay, this is what the problem was. So I need to set the Y position to 0.7 on this background. So 0.7 for this one, and for this one, 0.7. I forgot to do that, so now they are aligned in one line. So moving forward, we have the background left. I'm simply going to drag it, set the background layer, and I am going to set the X position 48.8, 0.7 for the Y, and of course set the scale to 1.5, 1.5. Now these are just basic things, laying out things inside of the game. So nothing complicated, nothing, out of this world. Next, I'm going to go here and create an empty game object, and this one is going to be black. So I'm going to click here, black to right, and I'm going to attach a sprite renderer on him, and of course make him the background. But this time the sorting or order in layer is going to be 3, and here for the sprite, I'm going to filter for the UI sprite. There you go. Now we still don't see it. Don't worry about that. I'm going to first set it to be dark. Next, I'm going to set the position to 75.79. By the way, these things can be tedious. So you can download the complete project, as I said. So 38.26 and 108.12. And this is where this is going to be. As I said, you can download the complete project and you can just, copy all of these settings and whatnot so that you don't have to watch me do all of that. So basically that will be it. Over here, this is going to be our background or black one, right? So for this one, I'm going to set it 76.6 and minus 4.0 so 4094. There you go. This is where I want this one. And of course, I am going to resize it. So the X scale is 55.4 and the Y scale 34.8. There you go. So this was for the, black, as you can see. So now we simply need to, duplicate these and move them over here. So that's pretty much it. But I am going to, so this one is going to be black 2 left. And this one is going to be black 1 left. So for the black 2 left, I am going to set here the position to minus 75.79, and the position Y is going to be 2.154. There you go. And the scale, I'm simply going to leave it as is. I believe it can be, so 38.28. Well, yeah, 28, and over here 104.97. Just said I'm going to leave it as is, and then I change it. I am a weird person. So the X position for the black one left is going to be minus 76.6, and the Y is going to be minus 3.68. The scale is going to be 55.4 for the X, 34.8 for the Y. That would be it. And now I am going to take the up and down, which is this one, up and down BG. See this bad boy over here, and I'm going to position it over here. Of course, we don't see it, so that's why I'm going to go to the background and set the sorting or order in layer to 2. Now for this one, I am going to change also the color to black, as you can see, and I am going to position this one. So Y position is going to be or actually 7.94. Now the scale for this one, so for the X is going to be 4.67 and 0.457 on the Y. There you go. We simply need to, there's going to be the up black, so up black, just change like that, and this one's going to be down black. That is all there is to it. So simply take it and position it to negative 7.01. And there you go, blocking out the haters. Anyways, you can see this is our level. Now this is for the background, so we still have the black background, so I'm going to right click over here, and as I said, I know it's tedious, but this is the only tedious thing we're going to do here. So create the new game object. I'm going to call it black backgrounds. There you go. I'm going to right click and reset everything. So now we have the down left, which is the first one that I'm going to position, and of course I will have to set it on the player sorting layer, which is something that will surprise you. I'm going to set the order in layer to 5, and the reason for that is because you see here the player layer is rendered on top of the background, and when we have the player in our game, I want the player to be rendered on top of this element and not vice versa. We will see that in the game, do not worry about that. Now I'm going to position this one simply at minus 4.35, and it's going to stay here, but I'm going to flip the X position, and actually flip the Y, the Y sprite, not the X position. Flip the Y sprite, and again, if I select it, there you go, this is flipped. And if I go over here and take my circle here, this is, and if I, I'm going to fix this for the next video. So moving forward, we have the down right. So I'm simply going to duplicate this one and change the name from down left to down right. And for this one, I'm going to position him to minus 32 for the position X, and everything is going to stay the same. There you go. We also have the middle one. So for the middle, I'm going to take the down right, and I'm going to position it over here. And I'm going to call this one middle right, so middle right, and set the background sorting layer, actually set the player sorting layer, and set 5 over here. And this one is going to be at 32 on the X and 0.5 on the Y. And of course, we are not going to, leave it like this, because I'm going to set the Y scale to 1.5, and there we go. Look at that. So this right here looks like it's connected to the roof, and it looks pretty much amazing because, we create amazing things. What else can I say? So taking the up middle, here it is, positioning it here, changing the sorting layer to background, and then 1, and then simply I'm going to set that to 5.61. There we go. So this one is going to stay on top. This is for the, as you can see, the up middle. Now we have the upright, which I'm going to take and put here, background sorting layer 1. There you go. 32 for the position X, and for our position Y is going to be 6.02. And this one is going to stay over here. I'm not going to change the scale or anything, and that will be it. And last but not least, copy the up right, and we're going to have the up left here. And the up left is simply going to be on the minus 32 position. So that would be pretty much it. And if I take the camera and if I move the camera, this is how our level is going to look like. Of course, you are free to experiment, do whatever you want. You can add more elements. You can even take all of these, you see all of these elements, and add them up to the last part of the level. That is your preference, but this is it for this video, and in the next video we're going to start creating the player. So this was, you know, the basic video, importing assets, creating the level, because this is my catch, this is my phrase, this is whatever you want to call it. Anyways, if you want to access all of these videos, you can access them right away in my Game Development Academy. You don't have to wait, because I'm going to publish these videos one by one. I believe there is anywhere, I'm still recording, this is the first video I'm recording, so I don't know precisely. You will know, because this is the future. Anywhere between 10 and 20 videos are for this tutorial series. So if you want to access them all right now and don't have to wait tomorrow for the next video and after tomorrow for the next video, you can do that. Link is down below. You'll support me, this cause, and, you know, enable me to create more tutorials like this. And anyways, I don't want to ramble, because, you know, people, probably a lot of you just quit watching this part of the video because I'm promoting, and I know you hate that, but I love it. And I will see you guys in the next video. So just imagine how stupid I was. It only took this. So it's basically right here. Here are the shapes. So you have the line, you have this, and there you go. This is how you, yeah. Okay, I wanted to get that out of the way, because, you know, crazy person over here. So moving forward, the first thing that this is now the second, because it's the second video. Now we're going to, you know, do the player, and, you know, don't get, you know, your dirty minds. We're not going to do the player. We're going to create the player. So over here, I'm going to right click and create a new folder, and I'm going to call this one animations, because, you know, we have to create the animations. And over here, I'm going to create a new folder for player animations, because we're also going to have enemies animations and all that stuff. So let's go over here in the Mad Doctor, and you have his animations, that idle, shoot, and walk. So I'm going to take the idle animation and basically the first frame, and put the player over here. We of course don't see him because he's a mad person, Mad Doctor, so I'm going to put him on the player layer. And this is what I meant when I said that these down below, look at this. So this right here, or this part of the background down left, so this one is going to be on the player layer, because if I put him on the background layer, look at that, the player is rendered on top of it, and, you know, it looks weird. This way, when you put him on the player layer, it looks a lot better, because, you know, the player is behind him and all of that stuff. So there you go. So there you go, basically. Anyways, over here, I'm going to click on the animation, or actually the name idle, and change it to player. Now, what I'm also going to do over here is I am going to set him or tag him with the player tag. I'm also going to go here for components, attach the animator component. This is, you know, one of the components. The next one is going to be a capsule collider. So I'm going to go here, capsule collider 2D. Don't confuse it with the 3D one. So this one, no. Well, basically I cannot do that. So capsule collider, this one, no. Capsule collider 2D, yes. So this is the one that we want. And you see, it's, you know, like a circle. It's weird. So first I'm going to make him a trigger. Next, I'm going to set his X position to -0.2. The Y position is going to be -0.75. The size X, I'm going to say 1.21. And the size Y, 1.21. There we go. So this is going to be right here. Hopefully you can see that. So this is right here, the collider. And we don't need more than this. This is sufficient for what we want. Make sure it's a trigger, so make sure that you do that. Next, I'm going to attach a rigid body 2D. Again, the rigid body, no. Rigid body 2D, yes. So attach the rigid body, and we do need to set the gravity scale to 0, because I don't want the player to fall down. So if you can try that on your own. If you leave the gravity scale to 1, he will just fall down, and that's on you. It's not on me, that's on you. So let's go over here quickly inside of our animations. So click here, animation, this animator tab. Actually, I don't have to. This one can stay over here. But in the animations, we need to, you know, create the animations. So we're going to have the idle, walk, shoot, and all that stuff. So I'm sorry. You see this? I have issues talking. Let's go over here in the animations first and right click and create the animator controller that I'm going to call player controller. And we're going to attach this one here inside of the animator of the player. So drag this over here, and now we can create animations. So I'm going to click here, create, and the first animation that I'm going to create is going to be the idle. So idle. First, we are going to create all the animations, no matter if they are empty or not. Then I'm going to drag and drop one frame at a time for all the animations. So next over here, we need to click where it says idle and create a new clip, because we're also going to have the walk animation. So here I'm going to say walk, moving forward, create a new one. So we are going to have the shoot, and the last but not least, we're going to have the death animation. So let's go over here, and there you go, we have the death. And now we can drag and drop these animations. So going here into the sprites and Mad Doctor, first one is the death one. So simply select all of the frames and place them here. Next, over here I have the idle. So let's search for the idle animation. This is the one, select it, drag and drop it over here. Next, I have the shoot. So let's find it. Here it is, put it over here. And last one is the walk. So let's go walk and place it over here. Essentially, your animator is going to look like this, and that's totally fine. We're not going to create any parameters or whatnot. Instead, we are going to call these animations by name, which is going to be really cool because that's something that, you know, we didn't do that often. But anyways, we can just quickly preview these animations. So I can go here. This is going to be the idle one. So if I hit the play button, he looks a little bit weird. So what I'm going to do is go here, click on these three dots, and these three dots are, by the way, over here inside of the animation tab. So click on those three dots and go to the sample rate, and let's set it to 24 and see. Well, 24 is still looking a little bit weird, so let's say 30. There we go. 30 is totally fine. If I go here, yeah, 30 is totally fine. Now going back to the walk, and let's check it out. Yeah, it looks weird. So let's go here, sample rate to 24. I believe 24 will be for the walk. Nope. Again, I think I need to set 30 over here. There you go. 30 can do. Shooting. So let's check out the shooting. Yeah, shooting is a little bit weird. So 24. I believe 24 is going to be. Yeah, there you go. Yes, 24 for the shooting. And the death animation. Okay, he needs to, you know, definitely die a little bit slower. Well, not this slow. Maybe he can. So that's personal preference. I'm going to set it to 30, and let's see that. There you go. This is totally fine. Anyways, this would be it for this video. Of course, if you don't want to wait tomorrow for the next video where we are going to start creating the player script, make him move and all that stuff, just join my academy. You know, you don't have to wait. All videos are available right now, so you can start learning. You don't have to wait. And basically, not only that, but as you saw from the previous video where I promoted, you probably saw that part. This is the light version of the original game. The original game has multiple weapons. It has multiple enemies. It has score count. I mean, this one has a score count, but that one has a better score count and all of that stuff. So just join, and that would be it. I will see you guys in the next video. What is cracking, peoples? Moving forward, now we are finally going to code the player's movements. So over here, I'm going to right click and create a new folder, and I'm going to call it script folder. And inside, of course, we're going to create another folder and then another folder, and no limit to the folders that we're going to create. So over here, it's not PP, it's player scripts, and inside the first one is going to be our player movement. So C# script, and this one's going to be player, not C, movement. There you go. I'm going to double click this, open it over here, and of course, there you go. So a lot of you guys have been wondering, what am I talking about when I say access all the videos? Well, basically, in my game development academy, you can access all of these videos. You don't have to wait every single day for a new video to be published. So yeah, link will be down below. This is it. So clicking this right, you're actually dragging on the player. We will attach the script. So what do we need when it comes to the player's movement? Of course, we need a few variables. So first things first, over here we have the serialized field. This one's going to be private float move speed, the speed by which we're going to move the player, which by default I'm going to set 3.5. I've set it over here to be a serialized field. You get the point. We can change it inside of the inspector. Next, I am going to have another serialized field, and I accidentally pressed escape on my keyboard, so it will not give me autocomplete. So this one's going to be a private float minimum. So minimum bound underscore X, and that's going to be equal to -71. And next we're going to have the maximum bound underscore X, which is going to be equal to 71. Minimum bound underscore y. This one is going to be equal to minus 3.3f. And last but not least, maximum bound underscore y, which is equal to 0. What the hell is this, teacher? Well, we are going to strict the player's movement. So he is going to have the bounds and basically the x and the y bound. So the x minimum is over here, the x maximum is over here, and that will be it. Y minimum is somewhere around here. So basically 0, and y actually maximum is here and y minimum is over here. So the player will be able to move like this. For example, he will be able to go up to here and up to here. Let me just see here. So minus 3.3. So the player will be able to go up to here. This is the minimum where he can go, and the maximum will be up to here, which is 0 basically. There you go. So up to here, and that will be it. And of course on the x up to here, and you get the point. So this is what are these variables, or what do they mean? Next, I'm going to have over here a private vector 3, which is going to be temporary position, because I'm going to store the temporary movement, and a private float x-axis and the private float y-axis. And we are pretty much set up everything, or we have everything we need for the moment to make the player move. So I'm going to remove the start function. We are going to leave the update because the movement is going to happen in the update. And I'm going to create void handle movement. There you go. And what is this? Okay, there you go. Just move this. Handle movement will be called int update. So there you go. And I'm saying there you go too much. I know you're annoyed. Do I care? Do I actually care? Of course I do. I love you. So moving forward, I'm going to say x-axis is going to be equal to input.getAxis raw. And of course, over here, we are going to say horizontal. Now, you do know me. I am a man of science. I am a scholar. I am, well, basically none of those things. But what I love to do, instead of using this hard code values, I like to do this. And if you followed any of my tutorials, you know what is coming. So I need to go here in the scripts and right click folder, and I'm going to call this one helper scripts. And inside of the helper scripts, I'm going to right click and create a new tag manager. So tag manager. And what this script is going to do, it is basically going to contain all the tags, all the axes, for example, in this case, all the animation names and everything that I'm going to use strings for. I like to put them here. And I also like to remove everything. So for example, I remove this, it doesn't inherit mono behavior. I remove this and I make it a public static class. Basically, I'm just going to paste everything that we need. You can pause the video right now. Like literally, if you don't pause the video right now, I'm going to shoot you. And I'm not going to comment on that one. So basically over here, we have the public static class and all of the public static variables, such as the horizontal axis, the vertical, the animation, the tags that we are going to use, and I'm going to just leave them here right now so that again I don't go back and forth when we need the player tag. Oh, let's go in the tag manager and put the player tag there, and then we need the enemy, let's go back. So no, here are all the tags, animations, and everything else that we are going to use string wise. So pause the video and copy it. So I'm going to assume that you did that, and over here now, instead of using horizontal like this, I'm simply going to say tag manager dot horizontal axis. It's the same thing, but this time we have everything in one place, which is the tag manager. It's much more easier to manage. It's more error proof, way easier to debug and all of that stuff. Next, we're going to have the y-axis, which is going to be the same thing. So input get axis raw and tag manager y-axis, or actually vertical axis. So vertical axis, there you go. Now, what is this get axis raw? Now, in case if you don't know, because we do have this, we have get axis and we have get axis raw. Basically, get axis will return 0, -1, or 1. So if we go to the left side, it will return -1. If we go to the right side, it will return 1. If we are not touching any buttons, it will return 0. What is the difference between get axis and get axis raw is that get axis will return 1, -1, or 0 right away. But get axis will return, for example, -1 point, let's say 0, 0.1, 0.2, 0.4, and so on and so forth until it gets to 1. The best way to do this, now this is, on you, debug.log, use input get axis and get axis raw, and you will see all of that. I now want to move on to the animation. So temp position is going to be equal to transform.position, and this is getting the temporary position from the player. Next, I'm going to say temp position dot x plus equals x-axis. Next, I'm going to multiply with the move speed and multiply with time dot delta time. So move speed, or actually get axis is going to determine if we are going to the left, right side, or if we are stationary and not going anywhere. So if we press the key code D or key code right arrow, this right here is going to have a value of 1. So 1 will be multiplied with move speed and delta time to smooth the movement. If we press the A key or the left arrow key, this will return -1. So -1 will be multiplied with this, making it a negative value and going into the left side. That's the whole philosophy. Temp position dot y is plus equals the same exact thing. So y-axis multiplied with move speed multiplied with time dot delta time. And then last but not least, here at the bottom, we're going to say transform position is equal to the temporary position. But of course, we did forget one thing. If you can spot it, bonus points for you. If not, well, I am not going to give you bonus points. So if I hit the play button, we will see now the player is moving, but if I try to move up, there we go, I'm up and I'm outside the screen. If I try to move down, there we go, and there we go, I have disappeared. So we need to, check the bounds. So over here, before we assign the temporary position back to the transform position, we are going to test if our temporary position dot x, if it's less than the minimum bound x, then the temporary position dot x is equal to the minimum bound x. It's simple, basically, when you just think about it. So this is the minimum side, this is the maximum side. If we go outside the minimum, so our x is less than the minimum, we're simply going to return x to the minimum. That's why we're setting temp x is equal to bound or minimum bound x. Same way if if our temporary position dot x is greater than the maximum, then we're going to say temporary position x is equal to the maximum. There you go. Very, very simple. If our temporary position y is less than the minimum y, then our temporary position y is equal to the minimum. So it's min y. There you go. And if our temporary position dot y is greater than the maximum y, then our temp position dot y is equal to the maximum y. That's all there is to it. If I go back, now when I hit the play button, we will still be able to move with the player. We will not see any differences. But now if I try to go out the bounds, there we go. It's not allowing me. If I click on the player, look at that. So his position is going at the up to 0. If I go down, there you go, up to 3 minus 3. It's not going to allow the player to move below that value. And of course, the camera is not following us so that we can actually see that we can go up to here on the... No, what is this with the detectation? So as I said, the camera is not following us to see that we can go up to this position on the X and, up to this right here, somewhere around here on the Y. So that would be it when it comes to this video. Again, I can move and all of that stuff. I'm pressing WSD keys. This is how I'm moving. If something is not clear, but basically we explained everything. This is just, again, basic logic, basic code implemented with logic. That's all there is to it. So we have you see y-axis getting all of that from the input, adding to the values, restricting the bounds and all of that stuff. But again, if something is not clear, make sure you ask in the comment down below. As always, if you don't want to wait for the next video to come out tomorrow, click the link below in the Game Development Academy. You have access to all videos, and I will see you guys in the next video. So now that we have the player's movement, let us also animate the player because he looks like a weird mad doctor, which he already is. So going here in the create script, C# script, this one's going to be the player animations. Actually just animation, but since I added S at the end, I'm simply going to remove it. And this is a lesson for everybody. If you change the name of the class over here, you need to make sure that you also change the name of the file, which is this one over here. That is mandatory for the script to work. So the name of the script over here needs to match up with the name over here. Otherwise, no worky. Okay, so over here I am going to have or tag the class and do my thing, hold enter and give space and all of that stuff. So going back over here, we are going to have a private animator anim, which is going to be our animator to animate everything. We are also going to have a private vector3, which is going to be the temporary scale, because we're going to handle the scaling, or basically changing the facing direction. And we're going to have a private int current animation. This is going to be the reference to the current animation that we are playing. Inside of the awake function, we are going to say anim is equal to get the component, and over here we're going to get the animator component from the game object, which is the player, and the animator component is attached on him. Now, one thing that we are going to do, public void play animation, and over here we are going to have a string animation name. There you go. And this is a nice technique that I saw from, I believe, Lost Relic Games. Yes, Lost Relic Games. This is, he put out a tutorial for this one. Instead of using all of that, like all of those parameters and having all of those parameters and stuff like that, we can simply just play the animations, because everything is wrapped around the code anyway. So for example, if the velocity is greater than 0, then we are going to move. So we can call to play the move animation instead of setting the trigger. But I have improved this a little bit, because he's comparing strings in his video, and over here I'm comparing integers, which I believe is a little bit faster. But still, I don't think there will be any difference in terms of, huge difference performance. So essentially over here, we're going to say anim play, and we're going to play the animation name. So animation name, which is basically the parameter, this one right here that we pass. Now, how are we going to compare and know that, okay, this current animation is playing? Well, we are going to test if the current animation, which is this one, and it's an integer. You're wondering now, how am I going to compare an integer? Well, over here, I'm going to use the animator, and I'm going to use string to hash, which is basically going to convert this right here. So it's going to convert this string into an integer. And from here, I'm going to say return. So if the current animation is being played, then we are going to say return. Over here at the bottom, we are going to say the current animation is equal to, and I'm simply going to copy this code over here so that I don't retype it again. And this basically is going to set the current animation to the animation that we pass as a parameter. So imagine this. Let's say I pass here the walk animation. So walk. And the current animation that's being played is the idle animation. So idle animation, comparing it to the walk, and this string to hash will convert this animation into an integer. So depending on the animation name, it can be, 0, 1, 2, 3, and you get the point. So let's say over here, the walk animation is on 1 and idle is on 0. So here I'm comparing 0. If it's equal to 1, which is not true, then I'm going to start playing 1, which is basically the walk animation. Then over here, I'm setting the current animation is equal to the walk, which means it will have a string of 1. So in the next frame, or next time I'm comparing if current animation is equal to the animation that's being passed, if the current animation is 1, and also the animation name over here that's being passed is 1, they are the same, so they're equal, and this will hit the return statement, and it will basically not pass below to replay that animation, because the animation is already being played and it's set on to loop. So there you go. We will not, there is no need to call play on the same animation again. Now over here below, I'm going to say public void set facing direction, which is going to take a bool face right, which is going to tell us if we should face right side or not. So if we should face the right side, then we're going to say temp scale.x is going to be equal to 1. Else, if we should face the left side, we are going to say face, or actually else temp scale.x is equal to -1f, and there you go. But we are missing 2 ingredients, and the first one is temp scale is equal to transform.local scale, first getting the scale from the transform property of the game object, and then we are going to change that based on if we are facing the right side, set it to 1. If we are facing the left side, okay, set it to -1. So over here I'm going to say transform.local scale is back to the temporary scale. And that would be pretty much it. We have everything or all the ingredients we need. We can go back over here. I can just remove this tag manager because we don't need it anymore. So over here, after our axes, I'm also going to create a private player animation that I'm going to call player animation. Simple as that. Inside of the awake function, I'm going to say player animation is equal to get the component called player animation, which is going to get me this component. And now I will be able to animate. But in order for me to animate this, I'm going to go below our handle movement and create the handle animation. What did you thought? I'm not going to create handle, I don't know, handle grandma. I'm going to create a handle animation. So going back over here, I'm simply going to paste the script, or actually the function name, because we need to call it in the update. If you don't call it, it's not going to work. Now there is a very cool way how we can animate our character. Basically the walk animation will be done if our get axis, so if the axis over here has a value greater than 0. And that's why I also created, if you are wondering in the beginning, why did I create these axes as separate variables and getting them here? Why don't I simply use this, so input get axis, and multiply it? So instead of this, I can do this. So over here, I can just do this and it will work still. Well, now I can do over here, I can say if my matf and the absolute value of the x-axis, if that value is greater than 0, or if the matf dot absolute value of the y-axis, if that is greater than 0, then I'm going to say here player animation, and I'm going to call play animation tag manager dot walk animation name. Over here I'm going to say else, if none of these are true, I am going to say player animation, and over here I'm going to play the idle animation. So essentially, why do I use the abs? Well, abs is the absolute value. We know, and this is not the first time I'm using this, the absolute value of every number is a positive. So if the axis over here has a value of -1, this will make it a positive, which means it will have a value of 1. Why is this important? Well, because I'm testing if it's greater than 0. That way I know it's moving. And if we go to the right side, the x-axis will have a value of 1. But if we go to the left side, it will have a value of -1. And if we test it here, if it's greater than 0, this will not be true. But still we are moving. The point is that we are moving. So I'm going to simply convert that negative value into a positive value and test it if it's greater than 0, because we know if it's a positive number, it will always be greater than 0. So that is the reason why I'm doing this for the y and the x-axis. And if I were to go back over here and test this out, we first of course need to attach this script on the player. So make sure that you attach the player animation on the player. And if I hit the play button, you will notice now the player is playing the idle animation. If I try to move, look at that, the player is moving. If I try to go back, well, the player is moving, but look at that, he's moonwalking. He's basically moving just a feeling. That was my impersonation of Michael Jackson. So there we go. We have issues over here, of course, the facing. And even if we go up and down, you see the player is being animated. And this is because, again, what I just explained, because of this right here, using the absolute value to test if we are being, if we are moving. So we know if this axis doesn't have a value of 0, we know that it is moving. If it's -1, we move to the left. If it's 1, we move to the right. But I'm converting it to the absolute value so that I know when always it's greater than 0, we are moving. So what do we need to do when it comes to the facing direction? Over here, I'm going to create void handle facing direction, which is going to do just that. So I'm going to copy it and go over here and put it right below the handle animation. But we do have a problem. How and what is the way that we can determine if we should change the facing direction or not? again, this right here comes into play. So we're going to get this x-axis, and I'm going to test it. If the x-axis is greater than 0, we are going to the right side. So I'm simply going to say here, player animation dot set facing direction to true. If you remember over here in the set facing direction for the player animation, we are using the Boolean value. If face right is true, we're going to set the scale to be equal to 1. If the face right is false, that means we're going to the left side, we're going to set the scale to -1. And if I go back over here, then we are going to test else if our x-axis is less than 0, then we are going to say player animation set facing direction to be equal to false. Because this way we will know if we should move to the left or to the right side. And if I go back and hit the play button, first of course, wait for everything to compile and all of that stuff. So now if I try to move over here, everything is working. If I go to the left side, there we go. I am switching the directions and basically the facing direction. If I go here, you will notice that the scale is currently set to be -1. And again, if I press the right and go here, there you go. If I move up and down, it's not going to change anything, but only if I move left. And that is the beauty why I have also used this x-axis over here, because the y-axis is not important. If we go up or down, we should not be changing the directions. There is no point. For example, if I go up, I change the direction. No, if I go down, I change the direction. No, there is no point in doing that. But if we, do this left and right, then there is the point of moving it. And we can know that easily by using the x-axis. If the value is greater than 0, which means if I press the D key, now the value is greater than 0. As you can see, we're facing, and I'm going to do that from this here. So I'm pressing 0, actually pressing the D key or the right arrow key. So I'm pressing both of them right now. We are facing, or we're going to the right side. So we set the scale to 1. If I press the A key or the left arrow key, there we go, I'm going to the left side, and you saw that now we are facing the left side. If something is not clear in regards to this video, in regards to what we created over here, the animation and all of that stuff, and how this is working, even though I have already explained it, but of course, I totally understand if somebody doesn't understand it right now, especially if this is your first tutorial and all of that stuff. Make sure that you ask in the comment down below, like the video, subscribe, and as always, if you want to access all of these videos right away and don't have to wait tomorrow for me to publish the next video, you can do that in the Game Development Academy, and I will see you guys in the next video. Now that we have the movement and the animations, let us add the functionality to shoot bullets. Basically, in this video, we're going to animate the player shooting, and from the next video, we're going to create the bullet and shoot it. But we need to start somewhere. So over here, right below the player animation, we are going to add a few more variables. The first one is going to be a private float, and as you can see, it's a serialized field because we will be able to manipulate it in the inspector if we need to. And I'm going to call this one shoot wait, so wait time, and that's going to be 0.5. Basically, we're not going to allow our player to shoot a gazillion bullets every single second. So I'm going to limit his shooting to basically a bullet per 0.5 seconds. So 2 bullets per second the player will be able to shoot. If we allow him to shoot more, it will be troublesome. He will be able to kill enemies without even, making an effort and all of that stuff. You get the point. So this is how much time we are going to wait before we can shoot again. Now, this private float variable, wait before shooting, is going to be the variable that's going to control that. So it's not shooing, it's shooting. And this is going to be, as I said, the variable in the code that we are going to use to control when we will be able to shoot again. Now, this is for the shooting. Now, the next one is going to be a private float, and this one is going to be move wait time, which is going to be equal to 0.3 seconds. Now, this move wait time is going to be the time that we need to wait when we shoot, because when we shoot, we're going to stop the movement. And this is what we saw in the preview of the game. So when we shoot, the movement stops, the shoot animation is being played, we shoot the bullet, and after we finish that, we will be able to move. This is how we are going to control that. Now, the variable, this is basically how much time we are going to wait. Now, the variable that's going to control that is going to be wait before moving. And last but not least, we also need a private bool, and this one is going to be can move, which by default is going to be equal to true. And we are going to use these 3 variables to determine when we will be able to move. Now, why do we set this can move to be equal to true right away. Well, over here inside of our handle movement, right here after we get the axis, I'm going to say if we cannot move, and notice the exclamation mark, then I'm going to say return. Notice the exclamation mark over here, which will make what's after it the opposite. Basically, this means if we cannot move, so currently we are shooting, we are not going to get all of this. So we are not going to, get these references. We are not going to test all of this and have the bounds and make the player move. Basically, it's going to be stationary in one place. Also, if we cannot move, over here in the handle animation, we are going to say if can move, then we're going to return, because over here we are animating the walk and the idle animation. If we are currently shooting, we are only going to be able to shoot, and we are only going to preview or display the shooting animation. So we're not going to allow the player to walk left and right and all of that stuff. Instead, the shooting animation is the one that's going to be played. So we need to strict that movement. Now over here, right below our handle facing direction, we are going to create stop movement, and this is going to be the first function in this series that we are going to use to create all of this functionality. Over here, it's going to be simple. When we call stop movement, we're simply going to say can move is equal to false to denote that this is when we shoot. So when we shoot, can move is false, and wait before moving is going to be equal to time.time plus the move wait time. And this is the timer that we are going to use to count if it's greater than, so if time.time gets greater than this timer, can move will be equal to true again. And that is going to happen over here in a function called void check if can move. And this is that function. So basically over here, we are simply going to say if time.time is greater than wait before moving, then we are going to say can move is going to be equal to true, and we will be able to move again. Now, where are we going to handle all this functionality? Well, inside of a function that I'm going to call shoot, and this is where the shooting is going to happen. So basically when we press the button, and this is going to be our key code, whatever we place, K, J, M, whatever. So when that happens, we are going to say here, wait before shooting is going to be equal to time.time plus the shoot wait time. This is to strict the player's shooting. So we will not be able to shoot again until time.time gets to the value that is greater than the wait before shooting. Then we're going to call stop movement, which is the function that we have just created, which is this one, which is going to say can move is false and wait before moving, reset that timer. And now we need to play the shooting animation. So we're going to say player animation dot play animation tag manager dot shoot animation name, which is going to simply play the shooting animation. And all of this is going to happen inside of a function that I'm going to say void handle shooting. Now, handle shooting and check if can move will be called over here inside of the update. So over here, we're going to say handle shooting, and over here, we're going to say check if can move. There you go. So handle shooting and check if can move. In our handle shooting, we are simply going to check if our input dot get key down. So if we press the key code, and we're going to say here key code K, you can change that to whatever you want. Key code B, C, J, K, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. There you go. Anyways, you can change that to whatever. I'm going to use key code K. And over here, I'm going to test if time.time is greater than the wait before shooting. And if that is the case, I'm going to say shoot, and there you go. So essentially, let me just revise everything what happened. So inside of our handle shooting, if we press the key code K on our keyboard and time.time is currently greater than the wait before shooting, we are going to shoot. In the shoot function, we're going to set wait before shooting to be equal to time.time plus the shoot wait time. If this is your first time here, because I'm using this technique a lot, basically what I'm doing here, time.time is the current time in the game. Basically, the measured time since the game has started. Let's say we are playing the game for 5 minutes, time.time is going to have a value of 300. and plus the shoot wait time. Plus shoot wait time is 0.3, or let's pretend it's 0.3. So let's say over here we have time.time, which is 300 plus 0.3. That means the wait before shooting is equal to 300.3. So over here, we need to wait until time.time gets to the value that is greater than the wait before shooting, which in this scenario is 300.3. So we will wait 0.3 seconds until we will be able to shoot again. I believe we set it to 0.5, but this is just for I've used these numbers in order to help you understand and explain. So this is what we are doing here. So we are resetting that value. Over here, we're stopping the movement. Can move is equal to false. So now, because we are shooting over here, as you can see, we are shooting, can move will be false, which will not allow the walk animation to play or idle animation to play, and it will not allow the player to move at all. And then after that, we are resetting wait before moving, which is again equal to time.time plus the wait or move wait time, which again is the same explanation as this one, except we're doing this for the wait before moving. Now over here, time.time is greater than wait before moving, and then we're going to say can move is true. And this is called in the update because we need to reset these values. If we don't reset can move, then we will not be able to move again, basically. So that's why we need to check if time.time, so the current value of time.time is greater than the wait before moving, then we're going to set can move is going to be equal to true. And that's pretty much it, what we are doing over here. And if I go now inside of our game, we can test that out. Now over here for the animator, I'm going to click on it while the player is selected, and we will be able to see, so let's move this over here. Basically, we will also be able to see the animation being played. So if I shoot, look at that, you see? And notice I'm pressing, so for example now, I'm pressing and holding key code A and I'm going to shoot. Look at that, how the character stopped. Look at the animations over here that are being played. Currently the idle animation is being played. When I walk, the walk animation is being played. If I go here and shoot, there we go, there we go, there we go, there we go. You see? So he is shooting, and of course we are not shooting bullets, but we are shooting with the animation. So you can see the animation is working and the system that we laid out is working. The only thing that is left for us to do is to shoot the bullet from here when we actually shoot or play the shooting animation. But the point is that we set up this functionality. Now, of course, if something is not clear in regards to what we have explained over here and all of these functions, make sure that you ask in the comment down below, and yeah, I will help you out. What else will I do? I will help you out to understand what is going on, and that's pretty much it. If you want to access all of these videos at once, you don't have to wait for me, tomorrow to publish the video. After tomorrow, you can finish them right away without waiting. That will be available inside my Game Development Academy, and that would be pretty much it. I don't have anything else clever to say. Far here from musters.com, and I will see you guys in the next video. Now that we have the player functionality for the shooting, that is the animation for the player, we also need to create a bullet for that to work. So in order to create a bullet, we do need to go over here inside of our sprites, and here is the bullets. I'm simply going to drag and drop him, and this is the bullet. Of course, you don't see him because, we are blind. Well, not that much, but we need to set the bullet on the bullet sorting layer. And also here, so we have the player game control. I'm also going to add the bullet tag. So I'm going to say here bullet. While I'm at it, I'm also going to add the enemy tag. And do we have more tags? I believe gameplay canvas. So gameplay canvas, let me just check here, gameplay canvas, there you go. So these are the tags that we have. I'm going to click on the bullet, and from here we're going to set his tag to be the bullet tag. Now, of course, you can see the bullet is too large, and we're not going to shoot the bullet like this, so it will look a little bit weird. So he goes like this, it's a, too large bullet. So what I'm going to do is set the scale X to 0.5 and scale Y to 0.5. Next, we are going to attach a circle collider, and it's a circle 2D. And of course, you will see over here, like, of course, that's something, you know, a general thing. But you will see because of the glow of this bullet, you will see that the circle is a little bit outside of where the bullet is. So we are going to set the radius to 0.28, which is a smaller radius. I'm also going to set or check the is trigger checkbox because, you know, why not? Why shouldn't we check the checkbox for the trigger? Yeah. So over here, I am also going to set or attach a rigid body 2D, and I'm going to set the gravity scale to be equal to 0. Now, this is when it comes to the bullet itself. I'm also going to go here, right click and create a new folder for the prefabs because we're going to now start creating prefabs for all of our elements in the game. So going back over here in the scripts folder, I'm going to right click and create a new folder for the bullet script. So bullet scripts. Basically, we're only going to have one script for the bullet, which is going to be called bullet. So practically there is no particular need to create a separate folder, but still, if you want, you know, to organize things and have everything in its place, it doesn't harm us to have a separate folder. But, you know, when you have, for example, I don't know, only single one script, like in this case, we can maybe put this in gameplay scripts or something like that, just so that we don't create a single folder for a single script. So going over here, what I'm going to do is remove all of this. And what do we need for our bullet? Well, in order to move the bullet, we need a private float move speed, which by default, I'm going to set that to be equal to 15. We also need over here a private float damage amount that this bullet will cause, and it's going to be equal to 35 by default. Of course, you see I set that to be a serialized field, which means we can change that value in the inspector. We also need a private vector 3, which is going to be our move vector. So I'm going to call it move vector, and that's going to be equal to vector 3. So equal to vector 3.0, which is by default. And last but not least, we're also going to have a private vector 3 temporary, so temp scale. And this is going to be the scale for our game object. Now, in order for us to move the bullet, I'm going to create a function that I'm going to call void move bullet, simply like that. And this is the function that we are going to call in the update. So over here in the update, I'm going to say move bullet like that. And inside of this move bullet, what's going to happen is we are simply going to take the move vector, and not player movement, but move vector dot x, and that's going to be equal to our move speed. So it's actually move speed multiplied with time dot delta time. And now I'm simply going to take the transform dot position. So this is the position of the bullet, and add to it. So I'm going to say plus equals our move vector. And that's pretty much it in order for us to move our bullet. Now, if I were to go back inside of the editor, if I hit the play button, we will see that the bullet is moving. So clicking here, if I hit the play button, as I said, you see the bullet just went away. And if I try to get it, you know, it's right here. There you go. So the bullet moved away, and we see that this is working. Now, there are actually two more things that I want to do here in the bullet, and that is I want to create a public void set negative speed. And because we will be able to shoot the bullet, and let me just get my drawing tool because I have restarted my computer, and here it is. So basically this is our player, and he will be able to shoot. So he will be able to shoot here, he will be able to shoot here. Now, if he shoots to the right side, that's okay. The bullet is going to the right side by this, so that is totally fine. But if the player shoots the bullet and he wants the bullet to go to the left side, we need to set the negative speed. Now, setting the negative speed is simply going to change the move speed. So we are going to multiply that. So multiplied equals to by -1, which is going to set the speed to the negative value. So when we set this over here, it will have a negative value. And also what we are, well, basically, we can also change the scale, but for this case, there is no need to. So there is no need to, but just in case, if you have a bullet that looks like a rocket. So for example, you have a bullet that looks like, I don't know, something like this, and you know, it's a rocket and fires over here, whatever, this is fire. So when you fire it, because it looks like a rocket like this, so this part you would have to rotate to face this side, so it looks like this. If you are, if it looks like that, basically. And how would you do that? You're simply going to say temp scale is equal to transform.local scale. And then our temp scale.x is going to be equal to negative of the temp scale.x. And last but not least, we're going to say transform.local scale, set that to be equal to the temp scale. That's all there is to it. And over here, as I said, the last step is on trigger enter 2D. And simply what we are going to do here, we're going to test if collision.compare tag. And we're going to compare the tag to the tag manager.enemy tag. And if we collide with the enemy tag, we are simply going to deal damage to the enemy. Now, of course, we cannot test this out because we do not have the enemy and we will not be able to deal damage. But what I can test out is this. Over here in the start function, I can not static, but start, I can call set negative speed just so that we can see that this actually works. And it will make the bullet move to the left side. So if I hit the play button, now we will see that the bullet is moving to the left side. There you go. And this is the effect that we want. So depending on if the player, as you can see, look at the player. So currently the player is facing the right side. So when he shoots the bullet needs to go from here to here. But if the player is facing this side, then when he shoots the bullet needs to go from here to here. So this is why we need the set negative speed. Now, of course, we will have to remove it from the start because we will do that from our shooting manager, so to say, script. And in order to do that, we will, start creating it in the next video. And that would be it. Hit the like, subscribe, share, comment, hit the like, subscribe. Just kidding. Anyways, if you want to access these videos all at once early on, you can do that in my Game Development Academy. You will not have to wait tomorrow for the next video, then after tomorrow for the next video. That would be pretty much it. If something was not clear when it comes to this video, make sure that you ask in the comment down below. But again, this is basic stuff. I'm always using basic code, but in combination with some logic to create really cool functionality for our games. Anyways, if it's, something is not clear, ask, I will help you out, and I will see you guys in the next video. In the previous video, we created our bullet, and now we need to shoot the bullet. In order to shoot the bullet, we first need to simply drag it over here and create a prefab out of this bullet. And I'm simply going to delete the bullet from the hierarchy right now. And what we also need to do is the following. We need to take the player, and I'm going to right click on him and create an empty game object. And this one is going to be our bullet spawn position because we need to know from where we are going to spawn the bullet. And what I'm going to do is tag it here with this whatever green circle or however you want to call it. And the position X is going to be 1.372. The position Y is going to be negative 0.887. And this is, or from here, is where we are going to shoot the bullet. So basically when we shoot, it is going to look like, like this, and shoot from here. So that is one thing that we need to do. Moving forward over here inside of our scripts folder and inside of the player scripts, I'm going to right click and create a C# script. And I'm going to call this one Player Shooting Manager. And this is the script that's going to handle the shooting for our player. And we need to select the player and attach the player shooting manager. There you go. And let's go over here, double click it and open this bad boy in Visual Studio, or I don't know, in Notepad, or I don't know, in your notebook, wherever you write your code. So what do we need over here? There's going to be a very simple script where we are going to have a serialized field. This one is going to be private game object. So game object, and this one is going to be our bullet prefab. Next, we are going to have over here a serialized field, a private transform, and this one is going to be bullet spawn position. And we are going to have only one functionality. So we're going to have public void shoot, and over here we're going to have a float facing direction. Now, why is this, or why do we need this facing direction? Well, the facing direction is going to determine if we should set the negative speed or not. Simply what we need to do here is we need to say game object, and I'm going to call it new bullet, and that's going to be equal to instantiate the bullet prefab, so bullet prefab, at the bullet spawn position dot position using quaternion, so quaternion dot identity. Next over here, I need to simply test if facing direction is less than 0, that means we are facing the left side, which means we are looking in this direction. So when we shoot, the bullet needs to go in this direction. If that is the case, we need to say over here new bullet dot get component, and getting the bullet component, and over here dot set negative speed, and this is going to set the negative speed for the bullet. And the negative speed is going to make the bullet, go into the opposite direction, basically to the left side. Now, where are we going to, or we need to call this here in the player movement, basically. So in the player movement, right here below our can move, we are going to declare our private player shooting manager. I'm going to call him player shooting manager. There you go. Inside of the awake function, we're simply going to get a reference. So we are going to say player shooting manager is equal to, and from here get the component player shooting manager, and that would be it. Inside of our shooting over here, after we, as you can see, play the player animation, we can call the shooting manager, and we can say player shooting manager with lowercase p dot shoot, and we need to pass the float, which is the facing direction, which is going to be transform local scale dot x, because we are using the local scale to basically make the player face the left and the right side. And I'm going to show you a couple of things why we did it the way we did it, so don't worry. First things first, inside of our player shooting, we need to draw this, drag and drop this, not draw, but drag and drop the bullet spawn position over here, and the bullet prefab. So here we have the prefabs, select the player again, and drag and drop the bullet prefab. So if I were to hit the play button now, and go over here, if I press the K, look at that. So now we are shooting, but we do have one problem, and that is these bullets, they are, look at that. So the bullets persist in our game, and you can see them over here inside of our hierarchy. Look at that. So we have the bullet, 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 which is, not efficient, as you already know. This is not something that, you want to be left in your game. So basically what we need to do is right click over here and create an empty game object that I'm going to call the collector. And for those of you guys who watch the collector movie, this is not that collector. This is not going to kidnap you and create traps to kill you. So over here, we're going to attach a box collider, make it a trigger, and set the offset position to, let's say, negative, 80. There you go, which is going to make the trigger be over here. And I'm going to set the size to 0.1 on the X, and on the Y it can be 20. And there you go. So this is one trigger or box collider. I'm going to copy this component and clicking on these three dots, by the way, over here. So you can click on that, and from there you can copy the component, and then again clicking, you can paste component as new, which will copy it and paste it with the same options. But over here, I'm simply going to set the offset to be positive 80. And now we have two, as you can see, one is over here and another is over here. And this is the collector who is going to collect these bullets. So going back inside of our scripts folder, and I'm going to right click and create a new folder for gameplay script. So gameplay script, something like that. And going inside, I'm going to right click, create a new C# script, and I'm going to call this one collector. And now I'm going to attach it on the collector game object. So click on that and go over here, attach it on the collector game object. And simply over here, you can assume we are going to have on trigger enter 2D, and we are going to test if the collision compare tag, and over here we're simply going to say tag manager, and this is going to be the bullet tag. If that is the case, we're simply going to call destroy on collision.game object, and there you go. So basically now if I go back inside of my game, we are going to see if I hit the play button, and no matter where I shoot, so I've shot on, both of these. So let's see over here. Here is the bullet. There you go. It hit the collector and now it's gone. And you can also see here in the hierarchy. For example, if I shoot, okay, 2 bullets, you can see we have 2 bullets in the hierarchy. Notice as soon as these bullets hit the collector, you saw that they disappeared from the hierarchy. Now, one thing that I want to address is the following, because a lot of you guys have, people say, like, why didn't I use flip X to change the direction of the player as opposite what we did over here, because inside of player movement, actually player animation, we are using the scale. Why don't we simply use the sprite render and flip X? Well, because I am using this right here. Look at that. So I'm using this right here as the spawn position where I'm going to spawn the bullets. If I use the flip X, look at that. So it's flipped. And notice here, I used flipped X, and if I press the K, look at that where the bullet is shooting, because when you flip the sprite. But when you scale, so when you use the scale and set the negative value, you change the whole game object, which means even the child game objects below it, such as the bullet spawn position that you see here. So over here, if I change the X to negative, look at that. So over here, you will see that the bullet spawn position has also changed the direction. So when we shoot now, it is shooting in the direction where the player is facing. But if I were to use the flip X that you see over here, if I were to use that, it's only going to flip the sprite. And also notice here, look at the collider of the player. So the collider of the player is here. And if I use flip X, look at now where the collider is. It's over here. So there you go. These are some of the, let's say, downsides when you use the flip property of the sprite render. But of course, depending on what you're doing, sometimes you need the flip, sometimes you need the scale. But I just don't want, because people think because the sprite render now has the flip option, okay, you don't need the scale ever. Depending on the situation, what you're doing, what you are trying to achieve, you might need the scale instead of flip. So just keep that in mind. Another thing that I want to point out, this right here, let's say for our purposes, and if you want to play this game on a computer, it's totally fine. You will not, it's totally fine to use instantiate. And also over here in the collector, we can use destroy, because we are limiting the shooting of the player, as we already know, because the player can only shoot if time is greater than the wait before shooting. And we know that wait before shooting has a value of 0.5, which means every 0.5 seconds, basically 2 times in a single second, we'll be able to shoot. So we will use instantiate 2 times in a second, which is not that much. So it's totally fine and it can work. But there are more efficient ways how we can use this, such as storing all of these game objects in a pool, and also in the original, well, basically in the heavyweight version of this game that you have in my Game Development Academy, I have multiple enemies, and those enemies also shoot. So I have enemies that are shooting, as opposed to here we only have one enemy that is attacking the player. So if you want to check that out, you can do that in my Game Development Academy. And over there, I use a single pool. So basically we have 3 enemies who are shooting, and I use a single pool, and those enemies fetch bullets from that single pool and shoot the player. So that's a much more efficient way, especially for mobile devices. But as I said, this will also work even on mobile devices. You will not see any bad hit performance, at least not on, how can I say, sooner devices. Well, earlier devices that are old 1, 2, or 3 years, you will not see that. Maybe on devices that are old 5 years, maybe you will see some performance hits, I don't know, but you can always profile that. Anyways, that is just for me to point out so that you know that there is a better way to do this. But hey, if you want to learn that, you can do that in my Game Development Academy. Plus, you don't have to wait for all of these videos to be published. You can access a better version of this game and all of that stuff. So yeah, link will be down below. Anyways, this is it for this video. If you have anything to ask, you can do that. But basically, these are just basic things: using instantiate, changing or setting the negative speed based on the facing direction, which we set over here. When we shoot, we simply pass the local scale, which will tell us if we are facing the left or the right side. And that would be it. And I will see you guys in the next video. Alright, in my game dev gangsteronios, now that we have the player, and he is shooting, and he is walking, and he is talking, and you get the point. We also need the enemy. So going back over here inside of the project and assets and sprites, and here in the enemy, you can see that we have his animation. So that, hit, idle, and walk. So I'm going to take the idle and simply place it over here. We don't see him because, we need to set him on the enemy layer, and bam, here is the enemy layer player. So over here, I'm going to tag him, or actually call him, name him enemy. Over here, tag him enemy, and I'm also going to set his scale to 0.8, 0.8 because I want the enemy to be a little bit smaller than the player. I don't want the enemy to be larger basically than the player. What I'm also going to do is attach the components. So we have the animator component that we need to attach on the enemy. We also have the capsule collider 2D. Again, you can see because of how the enemy sprite is created, the capsule collider is way, crazy places. So what we need to do is simply change the capsule collider. So what I'm going to do is click here to edit the collider, and I'm going to move this over here, move this over here, and move this down a little bit. So something like this. This goes over here. There you go. So basically this goes here, here, and here. And there you go. This is going to be our collider, or where we are going to place the collider. I'm going to uncheck or click again on the edit collider, and we are not going to be able to edit it again. I'm going to click here the trigger, so check the trigger checkbox, and over here the rigid body, I'm going to go rigid body 2D, and from here I'm going to set the gravity scale to be 0 because we don't want the enemy to fall down. Now of course, going back here inside of the animations, and I'm going to right click and create a new folder, which is going to be our enemy animations, and inside we first need to create our controller. So right click, create an animator controller. I'm going to call him enemy controller, and let's go over here and attach that on the enemy. So drag and drop the controller inside of the animator, and now we need to create the animation. So I can go over here, take this animation tab, click on the enemy, and create all of these animations. So the first animation, click create. First one is going to be the idle, so enemy is going to have the idle animation. So create a new clip. Enemy is also going to have the walk animation. Enemy is also going to have the attack animation. So attack. And last but not least, the enemy is going to have the death animation. So over here, we're going to have the death. There you go. And let's, create all of these animations by going into the sprite and enemy. First, we have the death. Select it. Drag and drop all of these here. Next we have, let's go back here, we have the hit, which is basically the attack. So I'm going to select that and put it over here. Next, going here, we have the idle. So let's find the idle. There you go. Put it over here. And last but not least, we have the walk. So from here, we have the walk, drag and drop it, and there you go. So if I move this, there you go. We have this over here. Let's check out the walk. It's a little bit weird. Enemy looks like a crazy person. So 3 dots, sample rate. Let's see 24. Yep, it works. Let's check out the idle. Yeah, I mean, for this one as well, we need to, let's go sample rate 24. Let's go over here. Well, 24 looks a little bit weird for the enemy. Let's go over here and set it to 30. It looks a little bit better. Let's see over here. Yep, it looks a little bit better. Let's try, let me go over here. Sample rate, let's say 25. Yeah, even 25 can do. Let's go over here to the death animation. Okay, we need to slow it down a little bit. So the death animation can be set on 24, I believe. Yep, 24 for the death. And last but not least, we have the attack. Definitely attack needs to slow down, so 24. Yep, there you go. And this is how the animator looks like. So if we select the enemy, this is how the animator looks like. We have the idle, we have the walk, and all of that stuff. We are going to use the exact same script we use for the player, just attach it on the enemy. You will see how that works because it's like a universal script, which is really cool. So we don't have to create a separate script for our enemy. And that will be pretty much it for this video. This is just the preparation for the enemy. In the next video, we are going to start to code the enemy and all of that stuff, make him walk, make him get to the player, make him attack the player, and so on and so forth. You get the point. If you want to access all of these videos early on, you don't have to wait tomorrow, after that day, after whatever. You can simply join my Game Development Academy. All of the videos are available right there, and also you have a more advanced version of this game where I have multiple enemies as opposed to only one enemy over here. And that will be it. I will see you guys in the next video. What up, game dev elves? Now what we need to do is create the script for the enemy. So going over here inside of the scripts and right clicking, I'm going to create a new folder for the enemy scripts. You know me, I'm the most organized person in the whole world. And here in the scripts, I'm simply going to say enemy and click on the enemy, and I'm going to drag and drop. if Unity allows me to. There you go, drag and drop the enemy script on the enemy. Now over here, I am going to tag the class and do, my thing, what good developers do, actually the best developers in the world. And over here, I am going to add a few variables. So what do we need? First things first. Anyways, we need the private transform, private transform player target. These are my silly jokes that probably nobody gets, but deal with it. So over here we have the serialized field, a private float, move, speed, and that's by default equal to 2. Now you can assume what this is. The player target is the target where we are going. So we need to get to the player in order to attack the player. The move speed is the speed by which we are moving. Next, we have the private vector, so private vector 2, and I'm going to call this one temp scale. And we are also going to have a serialized field, a private float, and this one is going to be our stopping distance, by default 1.5. It's a serialized field, which means we can change, the values in the inspector. And over here we have the private player animation that I'm going to call enemy animation. Now I have confused you there, but basically what we are going to do, we're going to use the enemy animation or player animation, to animate the enemy. So inside of the code, I'm going to call it enemy animation instead of calling it the player animation. We can probably create a universal script, call it character animation or something like that, and attach it on the player and the enemy, but I didn't do it, and I'm the best developer in the world, so that's the best way to do it. So inside of the awake, we are going to say enemy animation is equal to get the component, which is the player animation, and I started to type enemy animation. Also above this, I'm going to say our player target is going to be equal to game object find with the tag, and we're going to find with the tag manager player tag dot transform, because we need to get the transform since we set the transform to be the type of the player target variable. Now inside of the update function is where the AI for our enemy is going to stay or be, and we're going to call here void search for player. There you go. This is how I'm going to call it, and this is going to do just that, search for the player. So we're going to say search for player. There you go. Come on, if this works, there you go. Finally, search for player. And what's going to happen inside of our search for player, first things first, when the player dies, we're going to destroy the player. And if that happens, we need to test over here. If we don't have the player target, we are going to return. So it's simply return. And the reason for that is when we call destroy to destroy the player, and the player is not in our game anymore, and we call the search for player, this will return a null reference exception. So we need to test if we don't have a reference to the player target, then we are going to return, meaning this statement here will be executed, and after that, the code that's below will not get executed. Now over here we are going to test if our vector 3 and the distance between the distance between the transform position, which is the enemy position, so this is the position of the enemy, and the player target that position, if that value is greater than the stopping distance, then what we need to do? In this case, we need to go towards the enemy, or actually towards the player. So we need to say transform dot position is going to be equal to vector2 dot move towards, and it's going to move towards where? From the transform dot position towards the player target dot position in the move speed multiplied with time dot delta time value. Now, what the hell is this, teacher? This is the beauty of programming, and I talk about this a lot. When you want to do something in programming, you simply type out what you want to do. If you want your character to move towards, you type move towards. So this move towards will move from this position towards this position over here in this timely manner. So basically this timely manner is going to smooth out the movement. Think of it like that. So it's going to make the movement smooth. It's not going to jitter or whatever, but it's going to make the movement smooth. And it's going to go from the current position of the enemy, which is this one over here, towards the player target position. And notice what I tested over here. So if the distance, and again, the distance over here is going to give me the distance from this position and this position. So basically, if this position is here and this position is here, the vector 3 distance is going to give me the distance between those two points. So it's going to give me the distance between those 2 points. And if that distance is greater than the stopping distance, we are moving towards our player. Now over here, we can also do this. So right below, we can call the enemy animation and we can say play animation and passing here the tag manager walk animation so that we can preview or, simply have the walk animation. And if I were to go now over here inside of my game, don't forget that we also need to attach the player animation. So from here, player animation, make sure that is attached on the enemy. And if I move the enemy over here and hit the play button, it is going to get a reference to the player and it is going to get towards the player. And also notice it is being animated. So he's being animated, and now when he reaches the stopping distance, that's it. He is going to stop, but he is still being animated. That is his walk animation. The reason for that is because we didn't create any logic over here to do anything else. We are only going towards the player. So we're only going towards the player. Else over here, this is where the other thing is going to happen, which is the attack, and also check if the attack is finished and all of that stuff. So this is going to happen over here. But before we do that, I also want to show you one more thing, or how we are going to fix that one more thing. So if I hit the play button, we are going to see that the enemy is going or coming close to us. And there you go. So if I move over here, the enemy is coming towards us and the enemy will reach us eventually. There you go. If I try to move away, the enemy is going to follow me, but look at that. So the enemy is not changing the direction. So I'm going over here, but the enemy is not changing the direction. So what we need to do to counter this, what we need to do? Well, for this, I'm going to go back inside of the script and I am going to create here a script, or actually a function that I'm going to call handle facing direction, which is going to do exactly that. And we're going to call it right here below where we call the enemy animation to play that animation. So over here, what's going to happen is we are going to say our temp scale is equal to transform.local scale, which is going to get me the local scale from the enemy. And then how are we going to determine if we should rotate the enemy left or right? First things first, over here, transform local scale is going to be equal to temp scale, but in between, how are we going to know, should we rotate the enemy to the left or to the right side? Well, over here, I'm going to say if the transform.position.x, and this is the position of the enemy. If that position is greater than the player target.position.x. So if the current position of the enemy is greater then the player's position x, then we're going to say temp scale.x is going to be equal to matf absolute value of temp scale.x. Else, if that is not the case, then our temp scale, I'm simply going to copy this, basically copy it, and over here I'm going to set the negative of the absolute value of the temp scale. Why am I using negative and then the absolute value? We know that the absolute value is the positive value, and I'm setting here the negative because this is a better way than to do something like this. Temp, for example, temp scale.x multiplied equals to by -1. This will not work because, depending on how you structure this over here, you can get issues, you can have problems in your code. And I show an example why can this make issues in the full game course inside my Game Development Academy that you can check out. Link is down below. But anyways, this is also going to do the job. So if I were to go back now inside of the editor and if I hit the play button, we are going to see that when the enemy reaches the player and when the enemy starts to, follow the player again, it is going to change the facing direction. So there we go. And if I try to move away, look at that now. So he changed the facing direction. If I go here, look at that. So he is changing the facing direction depending on where the player is, and so on and so forth. So that will be pretty much it. We have the enemy AI set up, and starting from the next video we are going to code some more functionality such as attacking, detecting if the attack is finished, then dealing damage and all of that stuff. We also need to create the camera follow script, but that will come. Don't worry about that. These are, the fundamentals of the game that we are creating now. If something is not clear here, make sure to ask in the comment down below and how this functions, but we explain the distance in this right here, facing, the animation. We don't need to explain all over here, facing or handle facing direction as well. So that would be pretty much it, and I will see you guys in the next video. Of course, if something's not clear, ask and I will help you out. And I said this a gazillions of times, and you can access all videos. Link is down below, and I will see you guys in the next video. Okay, my game dev gangster bronios. Now, what we need to do with the enemy is inside of the else, we need to perform the attack. And that's going to happen right here below the handle facing direction. So we are going to have two functions. One is going to be check if attack finished, basically if the attack has ended. And the other one is going to be void attack. And both of these are going to be called, and let me just remove this because sometimes I get weird things for autocomplete. So over here, first we are going to check if attack finished. And next over here, we are going to attack. And of course, what's going to happen over here inside of our attack is that we are going to check if the time.time, if that is greater than the attack timer. But of course, you need to set up the attack timer if you want to have the attack timer. So that's going to happen over here right below our player animation, or basically the animation script that we're using. We are going to have over here a serialized field. One is going to be private float, attack wait time, which is going to be equal to 2.5. And this is how much you're going to wait. So every 2.5 seconds, the enemy is going to attack. And the reason for that is simple, because we are going to have multiple enemies, like 20 enemies are going to attack the player, and if all enemies can attack every second, they're going to kill the player pretty quickly. So over here, we are also going to have a private float attack timer. Next, we are going to have a serialized field private float attack finished wait time, and that's going to be equal to 0.5. We're also going to have a private float attack finished timer, and this is basically just to check if we should play the idle animation or not. So that is the reason why. So going back inside of our attack over here, we are simply going to perform a check and see if our time.time is greater than the attack timer. Then we are going to attack. And how are we going to attack? Well, it's simple. We are first going to say attack finished timer is equal to time.time plus the attack finished time. So here it is. It's actually attack finished wait time. So let me just see here. There you go. Attack finished wait time. Let me just type it out here. Finished wait time. There you go. There you go. Finally. And our attack timer is going to be equal to attack time, or actually time.time plus the attack wait time. And then we simply need to say enemy animation play, and we are going to say tag manager dot attack animation name. That's all there is to it. This is in the attack. Now what's going to happen in the if attack is finished, we are going to check if time.time is greater than the attack finished timer. If that is the case, we are going to say enemy animation dot play, and from here we're going to say tag manager idle animation. And that would be pretty much it. So if I go back in the editor, now when the enemy gets close to the player, I'm also going to go over here, make him get close. You are going to see that now he's going to stop and have the idle animation, and automatically he's going to attack the player. Look at that. There you go. And now he's in idle. And again, attacking, if we move, look at that. So he tries, or he gets to the, so there you go, he gets to the player. And there you go. Again, he's going to attack and attack and attack and so on and so forth. So how is it done? Well, basically over here, we are going to check if time.time is greater than the attack timer. Of course, after that, we're simply going to reset those values so that we wait. And as I said, we are waiting or checking for the attack finished timer. When that finishes, we are going to play the idle animation. So we don't want to play, the attack animation a gazillion times, practically. So that's what we are doing. Now, how can we detect collision, or how can we damage the player? So what do we need to do in order to damage the player? Well, in order to damage the player, I need to go back here in the editor and right here, select the enemy and right click and go here, create an empty game object. And this is going to be our damage area. And the damage area is going to be, I'm going to tag it here with this tag. It's going to be over here. For the X, negative 1.24. For the Y is going to be negative 0.321. There you go. So this is where we are going to set this damage area. Now I'm also going to right click over here and create a new C# script. And this is going to be the enemy damage area. And it's going to be a pretty simple logic, same as what we are doing so far. So I'm going to double click it and open it here in our Visual Studio. As I said, it's going to be a really basic logic, and we are simply going to do a raycast. So going over here inside of our damage area, we are going to say or create a serialized field. This one is going to be private float deactivate wait time, which is going to be equal to 0.1. And this is going to be the time that we are going to use to deactivate this script. And we are going to see why. So over here, I'm going to say private float deactivate timer. There you go. We are also going to have a serialized field. This one is going to be private layer mask, and that's going to be the player layer because, you know, we need the player layer. And that would be it. Of course, it's not done. It's not done. We are going to code a few more things, but I'm going to show you how it is going to be done. So over here in the update, we are simply going to detect if our physics2d, so physics2d dot overlap circle, so overlap circle, there you go. And we are going to overlap a circle at a position, but first let me, finish the statement. Overlap circle at transform.position using 1 for the radius and player layer. And if that is the case, we are going to debug.log. And over here, we're simply going to say collided or deal damage to player, something like that. So what is this overlap circle going to do? It's basically going to create a circle at this position. This is the radius of that circle, so something like that. And it's going to test for collisions with game objects who are set on this layer, which is the player layer. Anyways, so who is on the player layer? And in order for us to do that, we need to go over here inside of our, script. And first for the player, for the layer over here, I'm going to click on add layer, and we are going to create a player layer and click on the player again and go here and add him on the player layer. No, this object only. We don't want children to be on that layer. And for the enemy damage area over here, we're going to set the player layer. So let's test it out. We are going to see one thing or one issue that we are going to have, and then we are going to see how we are going to handle that. And look at that. Basically, we're damaging the player this whole time. Look at that. So 500, 600 times we have already damaged the player. The player would be dead in an instant if the enemy gets close to him. This is it for this video, basically setting up how we are going to damage the player and all of that stuff, which is going to be really, really cool, and we are going to see that, so don't worry about that. We're going to strict the damaging of the player and all of that stuff. Anyways, that would be it for this video, and in the next video, we're going to see how we are going to apply damage to the player only when the enemy attacks. We are also going to see how we can deactivate this damage area and all of that, so that you can see. We don't damage the player a gazillion times in a single second. If you have any questions about this, you can ask in the comment down below. But basically, these are basic things, nothing complicated. And same as here, we do need to add a few more variables, which we will do from the next video. But again, if something is not clear, ask in the comment down below. And if you want to access all of these videos, you don't have to wait. Link is down below. In the Game Development Academy, you will access, 80 more courses. What's better than that? There is literally, I don't know, how can I say it? Literally. There you go. Literally, there is no better Game Development Academy on the world than what I have to offer in my game development academy in terms of Unity and Unreal Engine. So if you find something better, please let me know. I want to see it. Anyways, I will see you guys in the next video. What is cracking the peoples? So now we are going to improve, so to say, the damage area, and we are going to start right here below our layer mask, and we are going to have a private bool, and we are going to call this one can deal damage. So this is going to determine if we can deal damage or not. We are also going to have a serialized field, which is going to be a private float damage amount, or basically how much damage we're dealing to the player. 5F is going to be the default one. Over here, we're going to get the player health when we create it, so don't worry about that. And over here inside of the awake, we are going to deactivate the game object. So we are going to say game object set active is false, because you saw that when the enemy got close to the player, basically the enemy was dealing damage to the player even though he was not attacking. So we need to deactivate this, and let me just see what this is. So we need to deactivate the game object as soon as we, run, because we are over here in the update. This is where we are detecting the overlap circle. We know the update is being called every frame, which means if we have 60 frames in a second, this will be called 60 times. And when the enemy gets close to the player, he will basically deal damage 60 times just for being close and nothing else. Now over here inside of our physics, we are going to detect if we can deal damage. So now if we can deal damage, we are going to say can deal damage is going to be equal to false, because we will not be able to deal damage again. And over here, we are going to deal damage to player, which is going to happen with the player health script. But over here below, I'm also going to create void deactivate damage area. This is if we don't deal damage to the player, we still need to deactivate the damage area. And we're going to test if our time, if that value is greater than the deactivate timer, then I'm going to say game object dot set active to be equal to false. There you go. And below over here, this is, by the way, going to be called in the update over here outside of this if statement for the overlap circle. So this is going to test if time.time is greater than the deactivate timer, then we are going to deactivate the game object. This is in case we don't deal damage to the player, because we need a way to deactivate this game object. And over here, we are going to have a public void reset deactivate timer, which is basically going to activate the timer. So I'm going to say can deal damage is going to be equal to true, because over here, if we already deal damage once, we're going to set that to be equal to false. So we need to reset it back to true to be able to deal damage again. And we also need to say deactivate timer is equal to time.time plus the deactivate wait time, because over here, as you can see, we're testing if time.time is greater than the deactivate timer, then we are going to set the game object to be false. So not active, basically. Now, of course, this will not work on its own like this, because we need to go over here inside of our enemy script, and over here, we need to create a serialized field. This one is going to be a private enemy damage area, and I'm going to call it enemy damage area like that. And we are going to go over here right below our attack, and we are going to create void enemy attacked function, which is going to be used in an event, which is basically an animation event. So over here, I'm going to say damage area or enemy damage area dot game object set active to be equal to true. So when we attack, we're going to reset and activate the game object, and our damage area dot reset activate timer. Now, this, as I said, is going to be called in an animation event. And in order for us to do that, we need to go back here and first select the enemy, drag and drop the damage area over here. There you go. And now go here into the animation and the attack animation for the enemy, and somewhere, let's say, around here. This is the frame where I want to call the function. So I'm going to, while I'm here on this frame, I'm going to press this button over here, which is going to create this whatever, this weird thing over here, which is basically the animation event if you take a look at here. And now I can select a function that is going to be bound to this animation event, which is enemy attacked. So let's test it out, and then I'm going to break the code line by line and see what we did. And if something is not clear, we will see there. So notice now when we get close to the enemy, look at that. So now we are attacking only once. There you go. So only attacking once again, but you know, we are basically not printing out anything. Let me just go back over here in the damage area, and you see we're just dealing damage. So we need to say debug.log, and over here I need to say damaged player, so that we can see that this actually works, because we don't have any feedback right now. We only have the animation. Let's get close to the player and we're going to see what is going on. So now when we get close, there you go, damaged player. And notice it's only printed once. It's not printed now twice because we dealt it now thrice or 3 times. But it's not printed a gazillion times like we saw in the previous video. So what is happening over here? Well, first things first, now we are controlling the damage with the can deal damage. And this is the damage amount that we will apply later on. So now over here, when we overlap with the player, so when we overlap, and that is true, so we collide with the player with this overlap, then we're going to test if we can deal damage. So are we able to deal damage? Because we're not going to deal damage, you know, a gazillion times in a second. As I said, the update function is called once per frame. And if we have 60 frames, this is going to be called 60 times. So it can happen that this collides with the player 60 times in a single second and deals, you know, 60 times damage. So we want to control and be able to apply that damage only once. And we control that with the can deal damage. So if we can deal damage, we are going to first set here can deal damage is false to ensure that we will not be able to deal damage again to the player in that second. And then over here we will call the player health function when we have it to deal damage to the player. Also over here we have the deactivate damage area in case the player is close to the enemy. So for example, if the player is close to the enemy and the enemy tries to attack and the player, you know, and the player tries to run away. So that is the reason why we need this deactivate damage area, so that we will deactivate the damage area by testing if time.time is greater than the deactivate timer. So if that is the case, then we are going to say game object set active to be equal to false. And over here, when we reset it, we are going to say can deal damage is true, which means over here this will be executed again when we collide with the player, so we will be able to deal damage to the player. And we're going to reset the deactivate timer and set him to be equal to the current time.time plus the deactivate wait time, which in our case is 0.1. So after time.time reaches the value where it is greater than the deactivate timer, it will again deactivate the game object. And over here, we have a reference to the damage area. So when we call the enemy attacked, which is a function that's being called inside of this animation event that we just created a moment ago inside of the attack animation, this is that damage event or animation event, not the damage. It's called an animation event. Basically, when the frame of the animation gets to here, it will execute this animation event, which in terms will call the function that we have specified here, which in this case is the enemy attacked function, which will activate the enemy damage area game object, and it will call the reset deactivate timer, which will do all of these things that we have just explained. So that will be pretty much it, what we are doing inside or for this functionality. And of course, we only need the player health to, you know, deal damage and all of that stuff. We will not start doing that from the next video. In the next video, I'm going to create a camera follow, and then we are going to create the player health and all of that stuff. Now, if something is not clear, you can ask as well. That is totally fine and normal. But my advice is try to, for example, don't execute this function. Try to do this. Call here return and see what will happen if you don't reactivate the damage area. When I say reactivate, you don't call set active and put it to true. Also over here, remove the deactivate damage area, remove that and see what will happen. So see what is the difference between when you have this and when you don't have it. And as I said, also you can see this right here. So when you don't execute this, or if you remove the can deal damage, that is the best way that you will learn. I can explain all of this and I can demonstrate that. But if you do that on your own and then you test it out and you see the difference and you're like, okay, now I understand. Because you're very smart, you follow Awesome too, it's the best programmer in the world, and you're smart. So anyways, that would be it. If something is not clear, as I said, you can also ask in the comment down below. If you don't want to wait for all the videos to come out, you can access them in the Game Development Academy. Other than that, or otherwise, I will see you guys tomorrow in the new video. Yo, what it is, Game Dev in the house. Now, moving forward, we are going to go here in the scripts folder and gameplay scripts, and I'm going to create a new C# script and call it the camera follow, not without the, so camera follow, not the camera follow. And I'm going to select the camera and I'm going to attach the camera follow script, hopefully, if Unity allows me, and there you go. So of course, let me do my best programming ever ritual by giving a little bit space, and you know, that's what good programmers do. And over here, what I'm going to do is get, or basically create all the variables that we need. So we need a private transform, and this one is going to be our player target. There we go. Next, we are going to have a serialized field. This one is going to be a private float smooth speed, which I'm going to set to be equal to 2, and this is going to smooth out the movement of the camera when it follows the player. Next, we are going to have here a serialized field private float, and this one is going to be player bound minimum underscore y, and that's going to be equal to -1, and this is up to where the camera can follow the player. So -1 is the bound on the y-axis, player bound, so player bound minimum underscore x is going to be equal to -65, and player bound maximum underscore x is going to be equal to 65. There you go. So this is up to where the camera can follow the player on the y-axis. This is on the x minimum, and this is on the x maximum. Now, next, we are also going to have here a private float, which I'm also going to set here to be a serialized field because we can change that value later on. I'm going to call it y gap, which is going to be equal to 2. This is the gap between the player and the camera. We will see that. And last but not least, we are going to have a private vector 3, and this one is going to be the temporary position that we are going to use to store in order to move the camera. Now, what's going to happen inside of the start function, we are going to get the player target. So I'm going to say player target is equal to game object find with the tag, and the tag manager is going to get the player tag. And we are going to say dot transform because this is the component that we need. Now, inside of the update function, before anything else happens, we need to make sure that if we don't have the player target, then we are going to return, because again, when the player dies, we are going to destroy the player and remove him from our game. And if the player is not in the game anymore and we try to run the code where we use a reference to the player, but that reference is now lost, then we will get a null reference exception. If you don't know what our reference is, what our class is, what our objects and all of that stuff, what are you doing following this tutorial? What are you doing? What? Answer me. I want to hear. No, just kidding, but you can go and watch my C# tutorial series where I explain that. So now over here, I'm going to say temp position is equal to transform that position. And of course, at the bottom, we're going to say transform position is equal to temp position to put it back. But in between is where we are going to set the values for the temporary position. So over here, I'm going to test if the player target dot position, so that position dot y, if it's less than or equal to the player bound minimum y. So if the player's position is less than the bound that we specified here, which is -1, in that case, I'm going to say temporary position is equal to vector3 lerp. And we are going to lerp from the transform position towards, and over here I'm going to say new vector 3, and we're going to say player target dot position dot x. For the y, we're going to say player target dot position dot y, and over here -10 for the z-axis. And it's going to happen in time dot delta time multiplied with the smooth speed to smooth things out. Now, what the hell is this lerp, teacher? I'm confused. I would like to, slap you in the face, teacher. And I'm like, no, don't slap me. Why? Why do you want to slap me? So if I hover over the lerp, it says linearly interpolates between 2 points. Basically, you see here, returns interpolated value equals to a plus b minus a multiplied by t. This is complicated. What essentially we are going to do with this is going to make sure that we go from this position towards this position in this timely manner. When I say this timely manner, it's not actually how much time it takes to go from here to there. Instead, it is using this time.delta time to smooth the movement out, so you don't see jitters like this. For example, you see the smooth movement like this. It goes in a straight line, even though this is not a straight line. But you don't see something like this, then like this, then like this, and you get the point. So this is essentially what we are doing. And this is if the player target position y is less than or equal to the bound minimum y. If it's not, so I'm going to copy this and I'm going to say here else, meaning the player's y position is not less than or equal to the minimum bound y, then I'm going to paste this over here, except now for the y, I'm going to add the y gap so that we have a gap between the player minimum position and the player's and the camera, basically. So when the camera follows the player, it will be a gap, and the gap is mainly because of this right here. So we don't want, for example, if the player gets over here, if the player gets up to here, we don't want the camera to follow the player like this. And then let me go in the game. We don't want the camera to follow the player like this, and it goes here, for example, like that. The reason why, well, because you see, we don't want to display our game like this. Instead, the camera will follow the player up to here. That is the reason why we are using that gap. And let me just take the player, put him back where he belongs. There you go. Now we are still not done. We do need to go back over here and make sure that we don't pass the bounds. So we are going to say if the temporary position dot x, if it's greater than the player bound maximum x, then we're going to say temp position dot x is equal to the player bound maximum x. And over here, if our temporary position dot x is less than the player minimum bound, then we're going to say temporary position, so dot x is equal to the player minimum bound x. There you go. So this is pretty much clear and self-explanatory. We're just testing if the current position of the player is greater than the maximum allowed position where we can be. So if that is the case, then the player's position is going to be the maximum, because we're not going to allow it. If this is the maximum, player's position gets to here, we're going to return it back to here and make sure it's equal to the maximum, and it will not be greater, or we will not allow it to go above the maximum. Same thing for the minimum. If it's less than the minimum, we are not going to allow that. Then we're going to simply say player bound minimum x is equal to this position, and that is going to make sure that the camera stays within the bounds of where it can follow the player. And this right here we explained, so it's going to go from this position towards this position over here. In this case over here, we're just adding y gap to the position y, and that would be it. Other than that, all of the code is basic code, just used with a little bit of logic. So if I go here and if I hit the play button, we are going to see now the camera is following the player. Look at that. So if we go here, look at that. So the camera is not allowing the player, so it's following up to here. It's not showing the you see this below thing over here. So it's not showing this part where we will have gaps in our game and stuff like that. So that will be it. So now I can, go over here and I can try to run away from the enemy and all of that stuff. And the enemy is searching for me and yada, yada, yada. You get the point. So the next step is to basically create the health for the player, the health for the enemy, start damaging them, and start killing them, which is why you came, didn't you? You little pervert. I know you. Anyways, just kidding. Or am I? Anyways, enough about me being silly. If you want to access all of these videos, link will be down below in the Game Development Academy. Otherwise, I will see you tomorrow in the new video that I will publish in this tutorial series. And yeah, if something is not clear, ask in the comment down below, and I will see you guys in the next video. Alrighty, my game dev gangsters. Now we are going to create the health for the enemy. So over here inside of the enemy script, I'm going to go and create a new C# script and call it the enemy health with alt the duh. Why am I saying every single time duh and then the name of the script? I don't know. Okay, do not judge me, and that will be it. So I'm going to attach enemy health, and by the way, I'm quickly going to go here and create a prefab out of the enemy, create a prefab out of the player, just so that we don't lose them here and then we need to recreate them again and all of that that stuff. So there you go. Let's go over here and double click this bad boy. You know me, you know the drill of the best programmer in the world, the best game developer ever who has ever lived, and that's me. So over here, what we are going to do is we are going to have a serialized field, and this one is going to be a private float, health, which is going to be equal to 100, which is the default health value. We can set it to a lower or a higher number, whatever, because it's a serialized field. And we are going to get a reference to the enemy script. So I'm going to call it enemy script, and we will see later on why we are going to need that. Over here in the awake, we are going to say enemy script is going to be equal to get the component and get the enemy script component. Now we are going to have over here a public void take damage, which takes a float parameter damage amount, which is going to be the damage amount that we are going to apply as a damage to the enemy. Over here, the first thing that we are going to do is we are going to test if our health is less than or equal to 0, then we are going to return, because there is no point in executing the code that's below where the enemy takes damage if there is no damage to be taken. If health is already 0, why should we deal damage? Simple. And if this is not the case, so if it passes this test, then we're going to say health minus equals the damage amount. And after we deal, the damage amount, we can do the following. We can say if our health is less than or equal to 0, and over here, in case you are displaying this with a text for the enemy, when I say this, I mean the health value, and you're displaying that to the UI, and you don't want the health to go below 0, you can say health is equal to 0, just to make sure that when you display the health to the UI, it doesn't, read -10. It reads 0, simple as that. And after that, well, we need to kill the enemy. So kill the enemy. And the killing of the enemy will happen inside of the enemy script. But before we do that, where we are going to deal damage to the enemy? The damage is going to be dealt here in the bullet. So over here, when we collide with the enemy and we see this is the enemy tag, we are simply going to say collision dot get component, and we're going to get the enemy health component, and we're going to say dot take damage, passing the damage amount that we already have defined over here, which is currently 35. And of course, later on, not later on, you can set it, because it's a serialized field, you can set it to 45, a gazillion, a 1 billion, that's, your choice. After we deal damage to the enemy inside of the bullet script, we are going to destroy the game object holding this script, which means the bullet will be destroyed because we don't need it. It has fulfilled its purpose. It will deal damage, and that would be it. Now, as I was saying, the destruction of the enemy will be dealt inside of the enemy over here. And what's gonna happen is, first things first, over here at the top, right below the enemy damage area, we need to create a private bool that I'm going to call enemy died. And this is going to determine if the enemy has died, because over here in the update, we need to say if the enemy died. So if that is true, we are going to return, because there is no point to search for the player if the enemy has died. Enemy is dead, he plays the death animation, he falls down, he lays down over here, so this is the enemy, so he cannot move left and right and try to search for the player and all of that stuff. Instead, he needs to die. The deer had to die. Ignore this. So right here below our enemy attack, we are going to create a public void enemy died function, which is the function that we are going to call here inside of the enemy health. So this is where, when the health drops to 0, kill the enemy. So we are simply going to say enemy script, and we're going to say that enemy died, which is going to call the function that we have just created. And what's going to happen inside of this function? Well, in this function, we are going to first say enemy died, and this is enemy died, which is our boolean, is going to be equal to true, which is this boolean over here, which means next time we run the update function and we see that the enemy died is true, it is going to return, which means the code below the search for player code will not be executed at all. After that, we simply need to go here and call the enemy animation to play the tag manager death animation. And after that, we need to destroy the player. And in order to destroy the player, right here below, I'm going to create destroy. So it's destroy the enemy after delay. And over here, we're simply going to say destroy, passing the game object, which is basically the game object holding this script, which is the enemy. So after we do that, so after we play the death animation, we are going to say invoke in string parameters destroy enemy after delay, and we're going to destroy the enemy after 1.5 seconds of waiting. So now when we deal damage with the bullet to the enemy, we are first going to see one issue that we will, see. Don't worry about that. So 1, 2, 3. There you go. Enemy has died, but the enemy played the death animation multiple times. That can be very easily fixed. We simply need to go here, click on the enemy and go into the animator tab. Click or double click on the death animation and uncheck the loop time that you have over here. So uncheck the loop time, and now when I hit the enemy 3 times, because it's dealing 35 damage, so 35, 35, we have one more, bam, look at that, the enemy has died, and now it is removed from the play. So essentially what is going on here, as a quick revision, when we hit the enemy with the bullet, we're simply going to test if we have collided with the enemy tag. If that is the case, we are going to get the component, which is the enemy health component, and we are going to, take damage or deal damage to the enemy. And the damage amount is going to be the amount that we specified here, which in this case is 35. Inside of the enemy health, and no, I do not want to annotate my cursor. There you go. For some reason I, clicked it accidentally. Or did I? Inside of the enemy health, we have the health at 100. And when we call the take damage, it is going to subtract the damage amount that we have here. So when the health gets to the value where it is less than or equal to 0, it's going to return. So it's not going to do anything. Basically meaning the code that's below the return statement will not get executed ever, 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 ever. Otherwise, we're going to subtract from the health the damage amount that we pass here. And we're going to test if the health is less than or equal to 0. Reset the health to 0. This is just in case you're showing that to the UI. And then call the enemy script to inform that the enemy has died. Inside of the enemy script over here, we're going to say enemy died is true. Play the death animation and call the invoke, which will call this function after 1.5 seconds. And this function is going to simply destroy the game object, which we saw in the preview as well. Now, if something is not clear, make sure that you ask in the comment down below. Other than that, I will see you in the next video. Also subscribe, hit the notification bell. That will help me a lot. Comment to push the video into the YouTube's algorithm. And if you want to access all of these videos at once, or even a more comprehensive guide to game development, or even a more better version of this tutorial, you can do that in the Game Development Academy. Link is down below. And I will see you guys in the next video. Now that we are dealing damage to the enemy, let us visually represent that to the player. And for that, what I'm going to do is right click and go here under UI and simply create a canvas. And this canvas is going to be our enemy health bar canvas. And what I'm going to do, I'm going to change the render mode from screen space to world space. And world space is simply going to make that canvas be in the world. So basically in the world where our characters are. And over here, the sorting layer, I'm going to set that to UI because I want the UI to be rendered in front of all other elements. Now over here, I'm going to set, or first things first, I'm going to attach the health bar on the enemy. Let's go over here. And this is the canvas basically. Okay, so all of this that you see, this rectangle is the canvas. So I'm going to resize it a little bit. So first set the position to 0, 0. The width is going to be 220 and the height is going to be 50. But over here for the scale, I'm going to set that to 0.0125. This is going to be the scale and also scale Y. So there you go. And now you can see this is the canvas. This right here, this small little rectangle is the canvas. And I'm going to set the height, or actually the position Y, to 0.79. And now we are going to attach the health slider. So over here, I'm going to right click on the canvas UI and search for the slider. And there you go. This is the slider. I am going to remove the handle sliding area. We don't need that. And over here for the fill and the background, I'm going to select both of these. And over here, I'm going to change the image to none, which is going to make them like a flat rectangle. There you go. The fill area over here is going to have a red color. And if I take the slider and if I, drag the value, there you go, you are going to see that the value goes, from 0 to 1. And basically what I need to do is rescale it. So this fill area over here, first things first, take this and move it up to here. There you go. And voila. Yeah, basically that's all there is to it. I just need to move the fill area up to here. And if I take the slider and move it right now, we're going to see, there you go. Actually, no. So the fill area can be taking this fill over here like that. There you go. And taking the fill area right now. So moving that over here. And now I believe everything's going to be fine. And this also needs to go up to here. This fill needs to move back a little bit. There you go. And taking the slider right now. There you go. Look at that. So it looks perfect. Now the value is going to go from minimum 0 to maximum 100 because that is the value that we have for our health. So from 0 to 100, and this is going to be our slider. Now for the slider, you see width is, well, basically this is okay. It looks decent, I think. I don't think that we need to change anything, I believe. So let's try like this, 916, and the height is 188. But over here, I'm going to change the scale to 0.2 and 0.2, and it looks a little bit better. Look at that. So it's, a little bit wider. And I believe that would be it for the UI. And over here for the slider, I'm going to simply call it health slider. So now, in order to display this to the user, we will need to go back in the health script. So in the health, enemy health that is, over here, we first need to say at the top using Unity engine.ui. So we need to use the UI, and over here I'm going to say serialize field and create a private slider, which is going to be our health slider or enemy health slider, however you want to call it. So it can be enemy health slider. There you go. And simply what we are going to do with this one is over here at the end. When I say at the end, meaning here at the bottom of the take damage. So after we deal damage and everything, we are going to say health slider dot value is equal to the health. There you go. So health slider value is equal to health. Now what we only need to do is go back over here and attach the slider to the enemy. So clicking on the enemy, going here, dragging the health slider, and that would be it. Let me just go here and apply all. So if I shoot the enemy right now, we're going to see, look at that, bam and bam, and we will have one issue. First, I can kill the enemy, and there you go, he falls down, and there you go, everything is okay. But we do have one issue, and that is the following. If I shoot the enemy, look at that, so you see his health, but if I run away from here, you see how the enemy switches the stance, and you will see that this health bar is also, it's basically flipped. You see, if I go here, again, it's going to be flipped. So maybe you want that kind of effect, if you want this kind of effect, because now if I shoot the enemy, you see from the left to the right, it will subtract the value. And going here, it will subtract from the right to the left. Of course, if you want that effect, you can leave it as is. No issue there. But if you do want to change that for whatever reason, you don't like it, we will have to do that here in the enemy. So in the enemy script here, right below where we have our enemy died, we are going to first create a serialized field, which is going to be a private rect transform. And I'm going to call this one health, not gelt, it's health bar transform, like that. And over here, a private vector 3, so not 2 and not 23. I'm going to call it health bar temp scale. Now, what the hell is this rect transform? Well, if I go back over here and if I select the canvas, you are going to notice one thing, that the canvas has a rect transform property, as opposed, for example, if I select the collector, who is a regular and normal game object, he has a transform property, as you can see here. But UI elements, they have a rect transform property. So UI elements, they have a rect transform, so it's called a rect transform as a property. And what we need to do with this one, we need to go select the enemy and drag and drop the enemy health bar canvas, so health bar, and there you go. Let me just override this so that this change applies to the prefab. And in order for me to change this, I need to go into the enemy script, and over here in the handle facing direction, this is where we are going to also handle the facing direction or the changing of the facing direction for the health bar. So I'm simply going to say health bar transform, or actually temp scale, is going to be equal to health bar transform dot local scale. So I'm going to get the local scale, and if the transform of the enemy itself dot local scale dot x, if it's greater than 0, then we are going to say health bar temporary scale dot x is equal to mat f absolute value of the health bar temp scale dot x. Otherwise, if it's not greater than 0, then we are going to say it's the negative of the health bar temp scale. And I type here tepm, not temp, it's tepm. So over here we need to say temp, for short for temporary. And let's go and change this. So here, 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 and here. And last but not least, we need to say here health bar transform dot local scale dot local scale is going to be equal to the health bar temporary scale. Now over here I can separate this health bar scale, just so that we know this is the scale for the health bar. So essentially we are getting a reference or to the values of the local scale of the health bar transform. We're testing if the transform local scale x, meaning the health bar of the enemy, or actually excuse me, the scale of the enemy game object itself, if the scale x is greater than 0, that means we are facing the right side. So we need to set the scale to the positive health bar temp scale, meaning the absolute value of it. Else, if the local scale x is not greater than 0, meaning it's less than 0, so we're facing the left side, then in this case we are going to set x value to be equal to the negative of the mat f absolute of the health bar. Basically, it's going to set it to the negative of the x current value. And that's pretty much it. Then simply put the scale back to the local scale of the health bar transform, which means now if I go back in the game and if I run it and deal damage to the enemy, we are going to see how that is going to look like. Look at now, so I dealt damage, and if I go here and he flips, you see the health bar still stays the same. So if I, deal damage, it's still dealing damage from right to left. And this is only visually. So basically that will be it. And now I can shoot him. There you go. He is dead. And voila, we have finished and won the game. Well, basically, we didn't. We still have work to do, but you get the point. This is how we create the health bars. If something is not clear when it comes to the render mode over here, I have this in my Game Development Academy. So if you're enrolled, you can watch the videos about that. I believe I also talk about this a little bit on my YouTube channel. So what is the difference between overlay, camera, and screen space, or actually world space? So you can have or access that as well. If you have any questions, make sure you ask in the comment down below. We didn't do anything too complex in this video, just, changing the scale and creating the health bar UI. And if you want to access all the videos at once, no waiting, you can do that in my Game Development Academy, along with, 80 other courses for you to learn game development, because there is no better game development library, training, course, lectures, universities than what I have to offer. That is, 100% like that. And I will see you guys in the next video. Now that we have our enemy health, it's only fair to have the player health as well. So going over here inside of our player script, I'm going to right click and create a new C# script, call it player health, not a brainer. And I'm going to select the player. and attach the player health on him. Now, over here, I'm going to double click this bad boy. You know the drill, and do all the things the best programmers in the world do. Basically, only me, nobody else. And over here, what I'm going to do is, first, I'm going to add a serialized field to represent the health. So this one is going to be a private float health, which again is equal to 100, same as with enemy, because we're going to start with 100. We are also going to have a private player movement. So it's player movement, and I'm going to call player movement. We will see why, because we are going to do something similar what we did with the enemy, basically the same thing, similar but same. Over here, our player movement is equal to get the component player movement. And from here, what I'm going to do is again create, same as with the enemy, public void take damage, which takes a float damage amount. And it is going to do the exact same thing what we did for the enemy. So first we're going to test if our health is less than or equal to 0. Then we're going to return, because there is no need to deal damage to the player if the health is already less than or equal to 0. If that is not the case, health is above 0, then we're going to subtract the damage amount from the health. And after that, we're going to test if our health is less than or equal to 0 to see if we have actually died, to denote that. So from there, we are simply going to call or inform that the player has died. Now, in order for us to inform that the player has died, we need the player movement. So this right here, and let me just move it so that we can get it close to the player health. What we need in the player movement is over here right below our player shooting manager. I'm going to create a private bool that I'm going to call player died, because same as with the enemy over here in the update, if the player has died, so over here, if player died, then we are going to return and not execute anything of these functionalities that we have built in, because if the player is dead, player is dead. After that, we simply need to, we need to inform that the player has died to restart the game and kill the player and all of that stuff. So we will not be able to move, we will not be able to animate, face or handle the facing direction and all of that stuff. So over here at the bottom, right below handle shooting, I am going to create a public void player died, which essentially is going to say that our player died is equal to true, same as what we did with the enemy. Call the player animation, so player animation dot play animation tag manager that animation, same as with the enemy. And after that, we're going to invoke, and I'm going to say here void destroy player after delay, which is essentially going to call the destroy on the game object holding this script, which is the player. So over here, we're simply going to say invoke, and in parentheses, well, first things first, after 2 seconds, but in parentheses, I'm going to copy this name and paste it here. Same exact structure, same exact signature. So basically everything what we did with the enemy. So it's the same exact explanation. So we have a Boolean value over here that's going to control if the player is dead or not. If it's true, then we're going to return here in the update and not allow all of this code to execute. And over here, we are going to call this public void function inside of our player health. So this is why we got a reference to the player movement, so that when the health drops to 0, we're simply going to say player died. And it is going to call the function. So it's going to call this player died function, which is going to set the player died to true. It's going to play the death animation, and after 2 seconds, it's going to destroy the player. That's pretty much all there is to it. Now, inside of enemy damage area is where that is going to happen. So over here, we need to get a reference to the player health. So we're going to say private player health, and I'm going to call that player health like that. Inside of the awake function, we are going to say, so over here, and I don't know why one of these parentheses was deleted for whatever reason, or curly brackets. So we're going to say player health is equal to game object find with the tag. and I'm going to call the tag manager and pass the player tag. And from there, we're going to say get component and passing the player health as the component that we want to get. So this is going to find the game object in the game who has a tag player and get the component player tag from him, so that now over here, instead of printing this using debug.log, we are simply going to say our player health.take damage, passing the damage amount that we have specified, which is over here. Currently, the damage amount is set to 5, but in order for me to display this or to demonstrate it, let me just see here. Yes, we have attached everything. I'm going to go here and apply that to all. I'm just going to take the enemy damage area and set the damage amount to 50 instead of 5, so that we can see quickly how the player dies. And even before we test it out, we know that the death animation needs to have this loop time unchecked, because we do not want to, basically replay the death animation. We saw that with the enemy, and there you go. So if I go here and hit the play button, we are going to see now when the enemy touches the player 2 times. So there you go, 1, and there you go, 2 times, there you go, the player has died, and now the player is deleted and he is removed from the game. Also now, because we have destroyed the player, we know inside of our enemy script. So let me just see, was it in the enemy script? I believe it was. Yes, it is. So if we don't have the player target, we're going to return, which means we're not going to search for the player. We are playing the idle animation though, but that would be it, because we already called the idle animation to be played. We're not going to search for the player again. He's destroyed because we called over here inside of player movement to destroy the player after he has died. Same setup as with the enemy. I don't think there is anything that we should explain here, but if something is not clear, make sure that you ask again here in the damage area, simply getting a reference to the player health, over here applying the damage, and over here subtracting that damage. So if the health is less than or equal to 0, do nothing, otherwise subtract from the health. If the health drops to the value less than or equal to 0, call the player died, and you saw the outcome. So the player died will make the player died true, play the death animation, destroy the player after 2 seconds, and that would be it. In the next video, we are going to create the UI for the player, and from there, we're going to start to wrap up our game. So if something's not clear, ask, I'll help you out. If you want to access all the videos and all future tutorials that I will be publishing like this, day by day, you can do that in the Game Development Academy, and I will see you guys in the next video. Alrighty then, Game Dev Gangsteronios, let us now display the player health UI. So right-clicking over here, going under UI and creating a new canvas, and I'm going to call this one Gameplay Canvas. So Gameplay Canvas, because he's going to display the player health as well as the score, how many enemies we have killed. So changing the screen space overlay to screen space camera, attaching the main camera, and setting the scale with screen size to 1920 by 1080. And if you don't know what this is, then you need to rewatch my other tutorials where I cover this, and basically you can find on YouTube and in my Game Development Academy especially about this, what this is. But even if you don't know, just copy these settings and follow along. So setting the sorting order or sorting layer to UI, there you go. Next, the first thing that we are going to create is going to be the health slider. So what I'm going to do is right click on the canvas UI and go here for the slider. And this one is going to be player health slider. And I'm going to set his anchor to the, like this, but I'm going to position him to -573 first for the X. For the Y, it's going to be 459. And setting here the width to 548, and the height is going to be 91. There you go. So now I'm going to set the anchor at the top left. Now from here, we are going to delete the handle sliding area, the fill area, and the background, changing their images to none, which will make them rectangular. Setting the fill to the red color, there you go. And let me just go here and again do my magic. First things first, take the slider and set the value maximum to 100 and set that to 100 over here. So now I will need to set the fill area to here, there you go, and to here, and set the fill back within the slider area. So now when I do this, there you go. It goes from 0 to 100 very, very quickly. So this is for the player health slider. Now, next I'm going to right click over here and create a new image, which is going to be our player icon to denote that who is, who the player. And I'm simply going to filter here for the icon. There you go. This is that icon. So I'm going to set the anchor at the top left. Position X is going to be 76, position Y minus 81. There you go. And the width and the height 120 by 120. This is how it looks like. Look at that. Pretty cool. Last but not least, we are going to have a UI text, which is going to represent the health, or actually the enemy. So enemy death count. Setting this one to the top left corner, so the anchor, the position X is going to be 322, position Y is going to be minus 201, the width is going to be 612, and the height is going to be 105. From here, I'm going to align the text at the middle, and left middle, that is. Over here, I'm simply going to say enemies killed, colon 0 as the starting point, because when we start the game, we didn't kill any enemies. The font size is going to be 50. Over here, the font itself is going to be this show G. And from here, I'm going to set the color to red, or to red. I set it to blue and then I say red. Over here, we see what we have. So enemies killed, and that would be it. Now, the last step in this video is to go inside of our player health and display our sliders. So over here, I am going to say using Unity Engine.UI, and right below our player movement is where we are going to get that slider or reference to the slider. So we need to say serialized field, private slider, and this one is going to be the health slider or player health slider, however you want to call it. And simply here, same as what we did with the enemy, inside of the take damage, I'm going to say health slider dot value is going to be equal to the health. And that would be pretty much it. We do need to go back and attach this because we set it to be a serialized field. So we need to attach it, and selecting the player. From here, drag the player health slider, and there you go. Override, make sure that this applies, or this change applies to the prefab. So now if the enemy attacks us, we are also going to display that same as how we are displaying with the enemy. Look at that. So bam, and you will notice at the top, look at that, how the health is being replenished, or basically how the health is dropping down and down and down. If I take the damage area and set over here the damage to be 20, it will, deal more damage. So there you go. I believe 2 more times or 3 more times, the enemy will have to, well, 1 more time. And now look at that, bam, the player has died. He has been removed from the game. And that would be pretty much it. The next step is to, restart the game after we die, and also, create the enemy spawner who is going to start spawning all of these enemies and then killing the enemies, and also displaying that score to the user and all of that stuff. So if something is not clear, and why did I run the game? So if something is not clear for this video, make sure that you ask, but basic stuff, creating UI, and that's all there is to it. If you want to access all videos, you know where to get them. Link is down below, along with, a gazillion other courses for you to learn game development with Unreal Engine and Unity. And now Unreal Engine 5 has came out. So expect more tutorials for that as well. And that would be pretty much it. Then I will see you guys in the next video. Now we have everything in place to create our enemy spawner. So going over here inside of the scripts and enemy scripts, I'm going to right click and create a new C# script and call it enemy spawner. Now, of course, let's create over here a new game object who is going to hold this script. Let me just reset the position and change the name to enemy spawner. And I am going to attach the script on him, but before we continue to code and do whatever with it, I'm going to right click on him and create an empty game object, and this is going to be the spawn position 1. And for this one, I'm going to set or tag it. So now I can set or move the spawn position somewhere around here, for example. And this is where we're going to start spawning the enemies. So minus, let's say 68. which means I'm going to duplicate this one, change the name to spawn position 2, and this one is going to be on plus 68. So if I go here, there you go. And of course, if I select it, I cannot see, but yeah, basically they are here. So one is here and one is here. And this is where we're going to spawn our enemies. So let's go into the enemy spawner script and do our magic, because we are going to have enemies coming into the game, and for that we need to spawn them. And the first thing that we need is going to be a public static enemy spawner that I'm going to call instance, because there's going to be an instance, since we will need to inform the enemy spawner whenever an enemy dies. And the reason for that is going to be simple, because we're not going to allow more than a specific number of enemies to be at the same time in the game. In our case, it's going to be 10, but of course we can change it to 20, to 30, to whichever number you want. Now over here, we are going to create a serialized field, and this one is going to be a private game object enemy prefab. So the enemy that we are going to spawn, which is basically only one enemy. And in my Game Development Academy, for the full version of this course, you have 6 enemies. So then we would create an array of enemies and all of that stuff. Anyways, over here, we're going to say private game object, and it's going to be the new enemy that we are going to create, because we need a reference to it. We also need a reference over here to a private transform array, which is going to be our spawn position, or positions. I'm going to call it position, even though it's an array, so that we can, later on get the random position from the array. Over here is what I was talking about. So we are going to have a private integer enemy spawn limit, and that's going to be equal to 10. So we're not going to allow to have more than 10 enemies inside of our game in any given point in time. So we can have maximum up to 10 enemies in the game. And how we are going to keep track of those enemies is by creating a list of game object, and I'm going to call this one spawned enemies, and that's going to be equal to new game object like this. And over here, I'm going to say serialized field, private float, and this one's going to be the minimum spawn time, which is 2, and the maximum spawn time, which is going to be equal to 5. So as you can see, the minimum and the maximum spawn time is going to be basically how much time it takes for us to spawn the enemy. So between 2 and 5 seconds. So between 2 and 5 seconds, we're going to spawn a new enemy. Inside of the awake function, we are going to test if the instance is equal to null. Then we're going to say instance is equal to this, so that we have a reference for the instance. And now we are going to create void spawn enemy functionality, where we are going to, spawn the enemies. Inside of the start function is where we are going to start spawning, and we're going to do that by simply calling invoke on the spawn enemy by using random.range between the minimum spawn time and the maximum spawn time, and there you go. So what's gonna happen inside of our spawn enemy is that we are going to say if our spawned enemies.count, if it's equal to the enemy spawn limit, then we are going to return. So if we already have reached the limit of how many enemies we have in the game, we are not going to spawn a new enemy. Otherwise, we're going to say over here new enemy is going to be equal to, and we're going to instantiate that by using the enemy prefab, instantiating it at the spawn position using the array over here, random, not transform, but random.range between between 0 and the spawn position dot length. And over here, we're going to say dot position and quaternion dot identity. There you go. So this right here is going to give me a random index between 0 and the length of this array, which is, either 0 or 1. So it's going to choose either 1 for the spawning position or 2. Simple as that. And after we do that, we need to say our spawned enemies add the new enemy that has been spawned, which is this enemy over here, this one that we have just created. So we need to keep track of those enemies, and we're keeping track of those enemies by adding them inside of this list over here. And you can see that whenever we, as you can see, serialized field, so that we will see that inside of our game. Now we still need to call this invoke again over here so that we can invoke the spawning of the enemy over and over and over again. So if I were to go back inside of the game, let me just lock the icons here because I want to drag and drop the spawned enemies. There you go. And over here, we still need to go inside of the prefab and select the enemy spawner and attach the enemy prefab. I am going to remove the enemy that we have here in the game. And now we will be able to see this is the spawn position. And what did I do? Okay, I need to remove this from here. So this one needs to be deleted. Can I delete it? There you go. This one also deleted. There you go. What I need to do is drag this over here. So spawn position 1 and spawn position 2. I have dragged them into the spawned enemies, which is not where we want them. So pay attention now. If I hit the play button, we will notice, there you go. So now when we start spawning the enemies, there you go, we have 1 enemy in this list, and the more enemies we spawn, so now we have 2 enemies and so on and so forth. Let's say over here, just for the sake of example, I'm going to hit 1. So I'm going to set the spawning limit to 1, and if I hit the play button, you are going to notice that now when we spawn only 1 enemy, there you go, we have 1, we are not going to be able to spawn any more enemies. So there you go, we only have 1 enemy. Now, what we need to do, and I'm going to shoot this enemy, and let's hope that the enemy dies. There you go, and he died. So the enemy has died. Notice what we have an issue over here. Look at this. We have a missing reference to this object, and I'm not sure if it will be able to. No, it will not, because it still has 1 for the count, and it will not spawn new enemies. So now our game is over. We will not have any more enemies in the game, and basically that would be it. We need to inform this right here. So every single time we add a new element, you see here we add a new enemy inside of this list, we also need to inform that the enemy has been destroyed. And we are going to do that by creating a public void enemy died, which takes a game object enemy as a parameter. And simply what I'm going to do is I'm going to call the spawn enemies, and here we are adding the enemy, and over here we're going to remove the enemy, and I'm going to pass this enemy right here. And where is this going to be called? Now this is the reason why I have created this as an instance, because inside of our enemy health, if I go back, enemy health over here, so now when the enemy dies, which happens over here, we are going to call the enemy spawner dot instance enemy died, passing the game object, which is this current enemy. So passing the current enemy to inform now that we have died. So now if I go back in the editor, we are going to see, if I hit the play button, we are going to see that the spawn enemy is currently 0, and we are going to wait until we spawn an enemy. There you go, we have 1 enemy, and I'm going to kill him. So I'm going to go here, shoot 1, 2, and 3, and now when I kill him, there you go, 1, 2, 3, bam, we don't have a reference to that enemy anymore. And I went to the 2D view. I want this. So we don't have a reference to that enemy, as you can see. And now we are going to spawn a new enemy. Or are we? Tricked you there, my brother. So can you think of why this is not working? Do you know why? Well, the reason is very simple. Sometimes you need to be careful how you write your code. Over here in the enemy spawner, look at this. If the spawned enemies.count is equal to the limit of the enemies that we can spawn, I hit return, which means all the code below will not be executed, including this one. So we'll not be able to spawn a new enemy again. So instead of putting that code over here, which is what the majority of people would do, you will have to put this as the first line of code that will be executed over here. So after we call the spawn enemy, immediately we're going to invoke it again and call it into the spawn time, so into the range of the minimum and the maximum spawn time, and then we're going to test if we have a limit, so if we reach the limit of the enemies that we can have in our game, and we're going to hit return. And then again, it's going to invoke and all of that stuff. So if I go back right now, and if I hit the play button, again, we're going to see that we have 1 enemy in the game. So let me just see where the enemy is going to be spawned. There you go, he's here. And if I try to kill him, so 1, 2, and 3. So now when he's killed 1, 2, and 3, look at that. So we don't have, and again, I went into the 2D view. And again, now we have a new enemy. So there you go. I need to kill this one again to demonstrate my point. 2 and 3, there you go. Kill the enemy. Look at here. Now the spawned enemies list is 1, or actually, excuse me, it's 0. We removed the reference to the spawned enemy. So now again, we are going to see we have spawned a new enemy, and it's not going to spawn new enemies as long as we have the limit of 1 enemy. So of course, I'm going to set the limit over here to 10, which was the default one when we started our game. And this is basically how we can control how many enemies we have in our game. Now, if something is not clear when it comes to this video, please make sure that you ask in the comment down below. Again, this is just basic logic that we have implemented with all of these variables, and we're just invoking and all of that stuff and then removing. Nothing new. But if, of course, if something is not clear, make sure that you ask. Also here in the enemy health, we are then removing the game object because we know that the new instantiated one, so this one right here, is the, enemy or the game object that holds this script. Simple as that. So yeah, if you want to access all of these videos, make sure that you subscribe to the Game Development Academy. Link is down below. And when I say all videos, you don't have to wait. So you don't have to wait for tomorrow for me to publish the next video, and after tomorrow the next video. And this is, I believe, the 17th video. I'm not sure. 17th, I believe. So 17 days I've been publishing these videos, and you can access them from day 1 and every next tutorial that I publish as well. So that will be it, and I will see you guys in the next video. Alrighty, my game dev gangsteronios, our game is shaping up really cool. So the next part is the gameplay controller, who is going to inform how many enemies we killed, and also who is going to restart the game when the enemy dies. So in the gameplay scripts, I'm going to right click and a new C# script. This one is going to be gameplay controller, as we already said. And what I'm going to do is right click here in the hierarchy, create an empty game object, call him gameplay controller, because how else am I going to call him? So controller, there you go. From here, reset and attach it. Voila. Double click it, and there you go. So what's gonna happen is that over here, let me just give a little bit of space. We are going to create or make him an instance. So he is going to be a public static gameplay. So gameplay controller that I'm going to call instance. There you go. And this one is going to be a serialized field, private text. Well, actually, I forgot to do that. So we need to go over here. Let's go here. What is it? Okay. So over here, I need to, use the UI. And now we are going to be able to create a private text, which is going to be the enemy kill count txt. There you go. We're also going to have a private integer enemy kill count, who's going to count how many enemies we have killed. Over here in the awake, we are simply going to say if the instance is equal to null, then we're going to say instance is equal to this to create an instance to this class. And simply this one is going to have 2 functions. Well, 2 that we can call, but 3 functions. So the first one is going to be public void enemy killed, which is going to inform us that we have killed the enemy. And simply what we are going to do here is we're going to say enemy kill count plus plus to increase the value by 1, how many enemies we have killed. And then we're going to say enemy kill count text dot text is equal to enemies killed colon, and here plus the enemy kill count. And that would be pretty much it. This is going to display how many enemies we have killed. Now over here, we're going to have a public void restart game, which is simply going to restart the game after 3 seconds. And over here, we're going to create void restart. This is what I meant when I said we're going to have 3 functions, but 2 that we are going to call. So over here in the restart, we are going to invoke. So in the restart game, we're going to invoke restart after 3 seconds. And in the restart over here, I'm simply going to say Unity engine.scene management.scene manager load scene, passing the name of the scene, which is the gameplay that we want to reload. Simple as that. Basic things that we did numerous of times. So now what we are going to do is inside of our player health. So this is where the player dies. We are going to say gameplay controller dot instance dot restart the game. So this is where the player dies. When the player dies, we're going to restart the game. And when the enemy dies in the enemy health over here, after we inform the enemy spawner that the enemy has died, we're also going to say gameplay controller dot instance dot enemy killed, so that we know that the enemy has been killed. And if I were to go here inside of the game and if I hit the play button, now of course what you can do for our, let me just go here, actually let me first see where the enemy is going to be spawned. Okay, there is one enemy, so I'm going to go towards him. You can create multiple spawning points where the enemies can be spawned, so that you don't have to wait for the enemies to get to you and yada 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 and all of that stuff. Here's one enemy, so I'm going to kill him. 1, 2, 3. Look at that. And null reference exception. Stupid teacher, because we need to go over here and attach the text. So from the gameplay controller over here, enemy dat count, there you go. This is that text. Otherwise, it's a no-no. It's not going to work. So if I hit the play button, come on again, let's see where the enemies are. Okay, one is over here. And I am going to get to it. So get to the enemy quickly as the mad doctor can move, because he's a mad doctor. There you go. 1, 2, 3. Look at that. Enemies killed 1. So 1, 2, 3. Enemies killed 2. There you go. And if I select all of these enemies, actually no, I'm going to select the damage area for this enemy. Let's say it's 50. There, well actually, yeah, anyways, you can see now the enemies are going to attack me, and when they kill me, look at that. So killy, killy, killy. There you go, there you go, there you go. Come on, come on, hurry it up, kill me. So when they kill me, bam. Okay, so I have died, and now the game is going to restart. There you go, and we play from scratch. That's pretty much it. If I go here, what we did is a basic script, nothing complicated. So we have an instance, we have a text, kill count, over here creating an instance, counting the kills, so plus plus over here, displaying that to the user, restarting the game. Basic stuff, basic stuff. If something is not clear, make sure that you ask in the comment down below. And also, your assignment will be to create a panel to display the final kill count when we die. You can do that as well, and you can also, as a challenge, create a save file where you're going to save the high score. So you're going to measure the high score when the enemies, you know, how many enemies you killed in the previous play, and so on and so forth. You get the point, what I want with that. Also, you can create a timer. Create a timer where you have a certain amount of time to kill all the enemies. Or for example, you need to kill, I don't know, 20 enemies in 2 minutes or stuff like that. So that will make the game more exciting. That will be your assignment. You can post it down below with any link for me to see and check it out. And yeah, that would be pretty much it. If you have any questions in regards to this video, make sure that you ask them in the comment down below. And I will see you guys in the next video. Of course, as always, you can access all the videos. Link will be down below. And not only this, because we're wrapping up, there is one more video left for this tutorial series, but for the future ones. After this one, we will see the next one, which will be, I still didn't create it, probably it will be Unreal Engine. So probably from, you know, the time in future when you're watching this video, I have like more tutorials lined up. So yeah, but probably it will be Unreal Engine. And as soon as I start publishing the next tutorial series, you'll be able to access all videos for that tutorial series in my Game Development Academy, along with other courses. And I will see you guys in the next video. What the is cracking game dev game peoples? Anyways, I don't know what that was, but this is the last part in this tutorial series. So we're going to create our sound manager, and over here inside of the scripts and gameplay scripts, I'm going to right click and create a C# one. So this is going to be my sound manager. There you go. I'm going to right click over here and create an empty, not the duty one, and I'm going to call it sound manager. And over here, reset the transform. First things first, I'm going to attach the audio source, and over here, I'm going to set this play on awaken loop, because this is going to be for our BG music. Now, for the BG music, what was that? Let me just remove this from here. So for the BG music, I'm going to set the volume, you know, let's say to 0.3. And of course, if I hit the play button, this is what we will hear, you know. You can pump out the volume. whatever, you hear the sound. Now I am going to set the volume to 0.3 because I want to hear the BG music. I also want to hear the enemy shooting. But this is just for the sake of example to show you how it is done. I'm going to uncheck these and don't need this at the moment because what's important is this one. So if I go here, we are going to have this public static sound manager instance. And we are going to have here a serialized field, which is going to be our private audio clip, which is going to be the shoot sound. There you go. In the awake, if the instance is equal to null, then we are going to say instance is equal to this. That's pretty much all there is to it. And over here, we're simply going to have one function that is going to allow us to shoot. So public void play shoot sound, which is simply going to call the audio source, not audio settings, but audio source dot play clip at point, the shoot sound at the transform dot position. Now don't worry about this, where we are playing it, it will not matter. We will still hear it in our game and all that stuff. And we're going to do that inside. I'm going to close basically everything. There you go. And over here, let me just find player scripts, player shooting manager. This is where it is going to be done. So I'm going to call the sound manager dot instance play shoot, not play, but play shoot. I wrote player shoot sound. It's play shoot sound. So let's go here. It's play, not player, but play shoot sound. And over here, everything is fine. Yep. So I can go here. And I can attach now the clip. So here is the clip. There you go. I can even turn this on. So it doesn't matter because I have lowered my volume a little bit. There we go. And I can now shoot. I can lower it. There you go. You can hear it because I'm recording the computer audio. And there we go. That would be pretty much it. There you go. Now, one thing that, we can do here is to improve the game is we can go and for the enemy spawner, we can create more spawning points, and they can be like here, 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 here. You get the point. So enemies basically can be spawned wherever. That would be pretty nice. Or even this, look at this. We can spawn enemies here and here and here and here. I didn't test it out, so you can test it out because they're moving where the player is. So we can, you can test it out just so that we can see if the enemies can be spawned from wherever. But that would be pretty much it. This was a very short video as a final video for this tutorial series. And yep. I don't have anything else clever to say. I cannot say if you want to access all videos because this is the last video in this tutorial series. But from tomorrow, hopefully, I believe, I have a new tutorial. So tomorrow, for the next new tutorial series that will start, you can access those right away in the Game Development Academy. Also, don't forget to subscribe and like the channel and all of that stuff. Help me spread the joy because more people need to see this. This is the joy that we spread to people. Anyways, thank you for watching this tutorial series. It's been an honor for me to teach you. This game is really fun, and the final or the original version of this game is much cooler. We have multiple enemies, like 6 enemies. We have enemies that shoot. They have advanced animations. All of that stuff, you can access that in my Game Development Academy as well. So yeah, Fi here from AwesomeTunes.com. I don't want to make this more salesy than it already is. Just kidding, but if you come to the doctor, you want him to cure you. I'm the doctor, the best in the world, and I'll see you guys in the next video.